Hello guys, and welcome to this full Python course for beginners.
Let's start by its definition. Python is an interpreted programming language, which means that it executes instructions directly and freely, without previously compiling a program into machine language instructions. It is also an object-oriented programming language, which is a programming paradigm that relies on the concept of classes and objects. It is used to structure a software program into simple, reusable pieces of code blueprints, also called classes. Python is a high-level programming language, which can be understood by most people, and this is one of the most powerful characteristics of Python. One of the reasons that Python is the best programming language nowadays is that it is simple and easy to learn syntax. It has some built-in functions and some characteristics that makes it easy and can be used by everybody in education, in software development, in data science, etc. It is a rich language with a massive number of modules and packages. This is also a very powerful tool of Python because it has some built-in packages such as math, numpy, scipy, etc. that you can use in order to develop and write your programs. You can also create your own packages with your personalized functions and import them using the import function in order to use them in your main program. It is developed under an open source license, which makes it free and open source, thus it can be used by everybody in all over the world. Here we can see the popularity of programming language ranking in 2020. As you can see, Python leads with a percentage of 30.34%. And this index is created by analyzing how often language tutorials are searched on Google. The more a language tutorial is searched, the more popular the language is assumed to be. This index can help you decide which language to study or which one to use in a new software project. Now we can talk about Python applications. Python is very useful and can be applied in so many fields, starting from web development, creating web applications using Django and Flask, dealing with web scraping using Beautiful Soup, internet protocols such as HTML and XML, dealing with requests using requests library, etc. It is also used in scientific and numerical studies. For example, NumPy and SciPy are very useful in data science. NumPy when dealing with matrices, for example, pandas when dealing with data analysis, and very useful to make data pre-processing. It is also used in data visualization with packages such as Plotly, Dash, Seaborn, Matplotlib, etc. Python is very useful in software development for build control, testing, etc. Can be applied in business applications, creating desktop graphical user interfaces using Decanter, and as we have mentioned earlier, with its simplicity and easy to learn syntax, it is also used in education. There are also some other uses of Python such as database access. As we all know, there are two types of databases. We have SQL and NoSQL. Python can deal with both SQL and NoSQL databases. For example, if we have a database and it is built under PostgreSQL, we can use PsychoGP2 in order to access our database directly from our Python code and write the instructions from our Python program. Also, if you are dealing with data types and data categories that are not in tables, which means that they are no SQL databases, we can use PyMongo in order to access our NoSQL database on MongoDB. Python can also be applied for game development using Pygame library. Now we will talk about some of the best jobs that you can get having the Python skills. As we have said and mentioned earlier, Python can be applied in so many fields. And with the skills that you can gain from this exciting programming language, you can apply for so many jobs. For example, data scientist and data engineer. Data scientist is one of the best jobs nowadays in United States and in all over the world because it is very useful for dealing with big massive of data, working with different databases, applying these skills in order to solve business problems. Software developer, data analyst, big data developer when dealing with a huge amount of data. It can be also applied in machine learning, deep learning, natural language processing because it has so many libraries and packages that can be used for deep learning. For example, we have TensorFlow, PyTorch, we have also Keras, and for machine learning, we can use scikit-learn, etc. Python is also very useful in computer vision and when dealing with images in order to apply it for image processing. I will show you how to install Anaconda Individual Edition, which is the world's most popular Python distribution platform, and also I will show you how to work with Jupyter Notebook. To start, you can write on Google Anaconda download and you will get this page. You click on Individual Edition Anaconda and we will get to this main page of Anaconda individual distribution. Before installing, I want to show you why Anaconda is very useful for a Python programmer in machine learning and in data science. As you can see here in the introduction, it is used over 25 million users worldwide. It is an open source and it is the easiest way to perform Python or data science and machine learning. Anaconda is an open source. It has over 7,500 data science and machine learning packages. With Anaconda, we can create different environments depending on our projects and on different packages that we are going to use. As you can see here in this page, we have given some different packages such as SciPy, NumPy, scikit-learn, pandas, matplotlib, etc. So these packages are the most used in Python for data science and machine learning. So after we install Anaconda Navigator, this is the main page that we will get in our computer. To install Anaconda, you can go to the bottom of this page and you will choose which one you want to download depending on your system. In our case, we are going to download Windows 64-bit graphical installer. So you click on that. So once you have downloaded Anaconda, you can click on it for the execution. Next. I agree. Then you choose where you want to install it. Click on next. Advanced options. So we don't need to add Anaconda to my path environment variable. Install. Right. So once the installation is completed, you click on next, next, and finish. Once you are on Anaconda Navigator, you can install Jupyter Notebook. Before start working with Jupyter Notebook, I will show you how to create another environment. This is the base route. To create an environment, you can go to Environments, Create, Name, create Python tutorial. Under Python 3.8, for the packages of Python, create it. Creating new environments depending on your project is very important. For example, if you are working with deep learning and you want to install some packages that are for deep learning, you can only, for example, use this one, Python tutorial. And here we have the installed, not installed, updatable, selected, all. This is about the packages that we have in our environment. So if you click, for example, on not installed, we have here the list of the packages that are not installed in our environment. To start with Jupyter Notebook, we can click on Launch. So once we are on this page, we can create new notebook. We can create a new Python 3, and here we have our notebook. To change the name, we write, for example, Python tutorial. And here we write the instructions. Print, for example, hello world, and run. We are going to talk about variables assignment, comments, and the different Jupyter Notebook cells. So, why do we need to assign values in Python? Well, when programming in general, we need to memorize values for late use. And in Python, to do that, we only need the equal sign. For example, if you want to put x to value of 5, we write x equals to 5 and we execute. To print, we write print x, and here we have 5. The value printed is always the last one in affectation. For example, if we do x equals to 10, we execute, then the printed value is going to be 10. Y equals 2. We use double quotes. Python, for example, we run it, print y, and here we have Python. We can also use single quotes. For example, y equals to new Python, execute, and when we print y, we will get the new Python. Here the remark is that in Python, the single quotes and the double quotes have no specifications, or there is no difference between double quotes and single quotes in Python. The only condition is that, for example, we have to use single quotes in the beginning and at the end of our string. For example, if we write y equals to double quotes Python, and at the end we will change it to the single quotes, well, we will get an error. One clue to good programming is comments. Comments in Python can give you indications about code for later use, tracing the variables functions of your code, help others to understand your code. It is important to know that comments are used in code files, so don't use them when working on command line. There are two types of comments in Python. We have single line comment with a hashtag and multi-line comments with triple quotes. For example, if you want to print or to use single comment, we use hashtag, and we write our comment. For example, this is a comment, and run. It will not be executed. For example, if we write print hello, it will be printed. But if we put it in a comment, there is nothing that is going to be printed. This is for the single line comment. If you want to print a multi-line comment, for example, if we want to print a menu, we can write like that: menu equals to triple quotes, and we can write our menu here. For example, we want to create a menu of a coffee. For example, we can write a question here: please pass your order. For example, we can write 1 for coffee, 2 for tea, 3 for example, chocolate, and if you want to quit, you can press, or you want to exit, you can press 4. So we write exit, for example, right? And we will put some space in here, right? Oops. And here we add another comment in here, for example, right? For example, we write this like that. And we execute our menu. For example, now if we write print menu, we'll get our menu like this. Now we will talk about the different cell types in Jupyter Notebook. We have 4 types of cells. We have the code, where we have written, for example, our function print. For example, this is a code cell, for example, and it will give us the result of the code. We have the second one, which is markdown. For example, later on in this tutorial, we are going to make reports directly on Jupyter Notebook. For example, if we have visualizations, if we have some explanations like we have did in here, we have to give some descriptions of our program, we can use the markdown. In the markdown, we will get this function. So this is markdown cell, and will directly print the output as text, not an output of a code. There is a third cell, which is raw MB convert. This cell type can be used to render different code formats into HTML or LaTeX by Sphinx. This information is stored in the notebook metadata and converted. Now we are not going to use this cell, and we pass directly to the heading. The heading is used to give, for example, titles or subtitles in our program. To start with a single hashtag, we can write, for example, this is a header, and it will give us a big title like this one. As long as we add hashtags to our heading, so for example, if we are going to use 2 hashtags, we will get a smaller title. It is a smaller title, for example. As long as we add hashtags, we will get smaller titles. For example, much smaller. Yes, so these are the different cell types in Jupyter Notebook. We are going to talk about one of the most important functions of Python, which is the input built-in function. For example, if you are building a web application or a user interface, you are going to ask a user to enter his or her email address, a password, a phone number, a name, a family name, etc. To do that, we use the input function. So the Python user input can be read using the input built-in function. The input from the user is read as a string. By default, it is a string, and it can be assigned to a variable. For example, if you write a equals to input, enter a month, for example, we run that. For example, we are going to write July. After writing your input, you need to press the enter key. So we press enter and we have July. As you can see here, we have the month and July are attached. To avoid that, we can leave space between month and the last code. So we do this, we run again, we press July, enter, and here we go. So for example, if we write type of A, it will be a string. For example, if we are going to input two numbers, say B equals to input, enter your first number, right? For example, we write 1 and we add C equals to input. We do the same thing, enter your second number, right? And we write, for example, 3. Okay. If we do print B plus C, normally we get 4, but in here we get 13. Why? Because the type of B is a string, and also type of C is a string. What we are doing here is concatenation. When dealing with numbers, you need to assign them to, for example, as an integer or as a float. To do so, we can write for here in B, we can modify it to int input B, right? We do the same thing, we write 1. Also for the C, we convert it to an integer, int run 3. Now if we print B plus C, we get 4. Type of B is an integer, type of C is an integer. And we do the same thing if it is a float. For example, if you write B equals to enter input, so enter your weight, for example, in kilograms. We are, for example, writing here 78.9. So type of D is going to be a string, but if we convert it to a float directly, $78.9, you have a float. We are going to talk about variables in Python. So, what are variables? Well, variables are containers for storing data values, which means that Python provides for your code memory locations in order to store data and values for later use in your program. They are also a way of labeling data with descriptive name, so our programs can be understood more clearly by the reader. For example, if you have a variable called x and you assign to that value x 38 degrees, the reader cannot understand, for example, if this is an angle, for example, angle with 38 degrees, or a temperature with 38 degrees. So what we are going to do in our program is that we are going to give a name for our variable so that the reader can understand easily our program. Variables do not need to be declared with any particular type. For example, if you have already, or some of you have programmed with C programming. In C programming, we need to assign the type of the variable at the beginning of each program before our main program. For example, you write int C, int A to assign this particular type. In Python, we do not need to declare our variables or to assign them to a particular type. And also, we can change the data type of a variable at any time we want in our program. For example, if we have an input x as an integer, and later on in our program, for example, we want to use this value in concatenation with another string, we can, for example, convert it to a string using the str function. So let's start, for example, by x equals to 3, right? If you want to know the type of variable, we just write function type x, and it will give us an int. If you want to convert x, for example, into a float, we write float x, right, 3.0. For example, if we have y equals to 3.14, we have type of y float, and we write int of y. We directly have the integer part, so we don't have the 0.14, we have only the integer part, which is 3. For city, for example, we can write, for example, London. It is a string, right? So we write type of city, it gives us a string. If we, for example, want to print x as a capital letter, we have an error. Name x is not defined, which means that Python is a case sensitive. Right here, x is different than the value of x because Python is case sensitive, right? We can also assign a value to city, which is equals to, we use single quotes, which is, for example, Rome, right? And when we print the city, we are going to get Rome because Python will change the value that is stored in city, which is London, by the latest value, which is Rome. As an output, we get the last value assigned to our variable. So as we can see here, we can use single quotes or double quotes for our strings, as long as if the value that, for example, we use single quotes Rome, and if we change here to single quote, it will be an error. Okay, so if we use here the double quotes, here we should also have double quotes, right? We have also another data type, which is Boolean. For example, we assign a value to b equals to true, right? As you can see here, we have t in capital letter and the rest is in lower cases, right? So if we run that and we write type of t, we will have boolean, right? We have a boolean. We have also f equals to false, same thing. So we have f in capital letter and the remaining letters are in lower cases. If we write type of f, so we have boolean. As a recap, we have seen the boolean, we have seen here we didn't assign that, so we add the cell type. We have cd is string, we have float, and we have an integer. We are going to talk about the operators in Python. Why do we need to know the operators and what are they used for? Well, operators are used to perform operations on variables and values. In Python, we have 7 types. We have the arithmetic, we have the comparison, logical, bitwise, identity, membership, and assignment. In this video, we are going to see each one of them in details. So we start by the arithmetic operators. Arithmetic operators are used with numeric values to perform mathematical operations. We have the plus sign for addition, the minus sign for subtraction, we have star for multiplication, the slash for division, the percentage assignment or the percentage sign for modulus, exponentiation with double star, and floor division. Floor division, it is a division except that it returns the largest possible integer. We are going to add a new cell. For example, we have a equals to 3, b equals to 10, for example. Okay, we add another cell. If we print a plus b, we have 10 plus 3 is equal to 13. If we do subtraction, we have minus 7 because a is less than b. But for example, if we do b minus a, we get 7. Okay, now for multiplication, we can do a times b, we have 30. For the division, we are going to divide b by a, so b divided by a, a is 3.33. For the modulus, we have b modulus a, it gives us 1. For exponentiation, we have, for example, 10 to the power of 3, and we'll have 1000. And for floor division, we have b double slash a, and we have 3. Now we talk about the comparison operators. Comparison operators are used to compare two values. We have 6 of them. We have equal, not equal, greater than, less than, greater or equal, and less or equal. For example, if we choose x equals to 4, y equals to 8. For example, if we write print x equals to y, we have false because 4 is different than 8. We have x not equal to y, we have true. For example, if we write x is greater than y, we have false. X is greater or equal to y, false. But if we do less than, it is true. Less or equal, so we have or. either one condition is satisfied. So the first one or the second one. We have less than, we have x is less than y, so we have true as an output. For the logical operators, they are used to combine conditional statements. We have three of them: and, or, not. And returns true if both statements are true, or returns true if one of the statements is true. Not reverse the result, returns true if the result is false. To try that, for example, we use z equals to 6 and f equals to, for example, 2. Okay, run. For example, print, for example, z is greater than 5 and f is less than 5. Okay, print, we have true. For example, if we do print z is less than 5 or f less than 5, we have one of them is true, so the answer is going to be true. Okay, we reverse the result. For example, here print not z, we directly copy that, right? Copy, paste, one, it is false. It reversed the result. It was true, now it is false because we have used the not operator. Now, when dealing with binary numbers, we have to use operators called bitwise operators. We have 6 of them. We have the AND, the OR, the XOR, the NOT, shift to the left, and shift to the right. Now, for example, if we have A equals to 7, okay, which is in binary 1, 1, 1, it is equals to 1 times q to the power of 0 plus 1 times 2 to the power of 1 plus 1 times 2 to the power of 2, which is equals to 1 plus 2 plus 4, which is equals to 7. Okay, now if we do the same thing and we choose B equals to 1, which is equals to 0, 0, 1 in binary, we just replace here. It is 1 times 2 to the power of 0 plus 0 times 2 to the power of 1 times 0 to the power of 2, which means that is equal to 1 plus 0 plus 0, which is equals to 1. Okay, we run that. If we print A and B, we will get 1. So the result is going to be 001 because we have 1 times 1 give us 1, 1 times 0 it gives us 0, and 1 times 0 it gives us 0. So this is the bitwise AND. We multiply or we do the same thing or the multiplication between each bit by another bit in the other variable. So we have 1 times 1, 1 times 0, and 1 times 0 we get a 1. For example, if we do print A or B, what we have here, we have 7. 7 is 1, 1, 1. Okay, in the OR we have set each bit to 1 if one of two bits is 1. Okay, so we have 1 or 1 give us 1, 1 or 0 give us 1, and 1 or 0 gives us 1. So we choose between 1 and 0, we choose 1. Okay, set bit to 1 if one of two bits is 1. It's the opposite of the AND, where we set each bit to 1 if both bits are 1. We have 1 and 1, we get 1. 1 and 0, we get 0. And we have the same thing for the XOR and for the NOT. For the shift, for example, if you want to shift, for example, we write print A shift to the left by B, for example, okay, we have 14, which means that we will get 1 1 1 0. Okay, so we shift this to the left, we have 1 1 1, okay, and we shift to the left by 1, we add 0. Okay, so we shift to the left and we add 0 in here. If we do print A shift to the right by B, we'll get 3, which means that we will get 0 1 1. Okay, so we shift to the right means that we add 0 1 0 here, and we omit the variable that is in here, whether it is a 0 or a 1. Now for the identity operators, we have 2. So they are used to compare the objects with the same memory location. So we have is returns true if both variables are the same object. Is not returns true if both variables are not the same object. For example, okay, if we have two we say two lists, okay, x equals to, for example, okay, 1 and 2, right? We have y equals to, right, 1 2, okay, and you put, for example, put a equals to x, okay, we run that. If we write print x is y, so we have false, even if x and y are the same and have the same content, but they have not the same memory location and they are not the same object, okay. But if we write print x is a, we have true, okay, because both variables are the same object, okay. For the membership operators, they are used to test if a sequence is presented in an object. We have two operators, we have in and not in. So in returns true if a sequence with a specified value is present in the object. Not in returns true if the opposite. Okay. For example, if we have, as we have here, for example, x, so we write 1 in x, okay, 2. If we write 2, okay, 2 not in y, we have false because we have 2 is present in y, okay. Finally, we have the assignment operators. They are used to assign values to variables. Okay, we have the equal sign, plus equal, minus equal, equal, division equal, so divide and assign, modulus and assign, exponentiation and assign, floor div for divide and assign. Okay, for example, if we have x equals to 5, okay, and we run that. If we do x plus equal to 3, print x, we get x equals to 8. So x equals to 8. It means that we have here x equals to x plus 3, which is equals to 5 plus 3, and we have 8. Okay, and it is the same thing for the other applications or the other operators that are used for the assignment.
We are going to talk about Python modules and packages. First, what is a module? A module is a file containing Python definitions and statements. The file name is the module name with the suffix .py appended. A module can contain executable statements as well as function definitions. The statements are intended to initialize the module. A package is a collection of modules. They are a way of structuring Python's module namespace by using dotted module names. For example, the module name a.b designates a submodule named b in a package named a. Modules and packages facilitate modular programming, which is the process of breaking a large and widely programming task into independent, interchangeable modules such that it contains everything necessary to execute only one aspect of the desired functionality. To import a package or module, we have two methods. We can use, for example, import the module math. For example, we run that. And to use that, we have to assign it this way, math dot, and we are going to use, for example, a function that is defined inside our module math. For example, we are going to use square root, right? Square root of 4. For example, we have 2. We can also import this module using another method, which is from math import, for example, square root. Okay, run. Then we are going to use it directly without using the math dot square root. We are going directly to use, for example, square root of 4. Okay, run. We are going to see all the functions that are in math module, right? Module math. So we have the name, which is math. Description: this module provides access to the mathematical functions defined by the C standard, right? So we have these functions that we can use inside the math package, right? For example, if we want to use sine, okay, sine of 30, for example, it will say that name sine is not defined because we did not import it from our module. Okay, but if we use math.sine, it will work, right? A better method is to use the star, for example, from math import all. So when we use this symbol right here, it means that we will import all the functions that are inside our module. So we have the access to all the functions. We execute that and we use, for example, the sine of 30. We get our result directly. For example, if we want to list all the packages that are in our Jupyter notebook, for example, we can use exclamation point pip and we just write list. Here we are going to have all the packages that are in our Jupyter notebook, right? So we have all these packages right here. For example, we have NumPy. If we want to uninstall, if we want to delete a package, we need to use this syntax, right? We write pip uninstall, right? And we have to write minus yes. Okay, so for example, this means that we are allowing to uninstall this package. For example, we can write numpy. Okay, uni install, yes. Successfully uni installed numpy. Okay, now if we want to install a package, since we have deleted numpy, we are going to install it again, right? Numpy. So this is used to uni install package. This is used to install the package, right? So here we have successfully installed numpy with the latest version, right? This function is for listing all the packages, and here we have these different methods for importing the functions inside a module, right? The help function, it helps us to get an insight of what functions that we will have access into from the package that we are going to import.
We are going to talk about Python keywords, which are the fundamental building blocks of any Python program. They are reserved words and they cannot be used as variable names, function names, or any other identifiers. To display our keywords, we use the help function. So we write help keywords and we get the list of the Python keywords. To make it easier to remember, we have grouped these keywords into small groups to make them simple to understand. First, we start by logical operators. We have 3 of them. We have AND, OR, NOT, which are used to combine conditional statements. For example, if we have x equals to -6, y equals to 5, and we write x is negative and y is positive, so we get a true. If we write print x is positive or y is positive, so we have y is positive, and the OR statements returns true if one of the statements is true. Since y is positive, so we get a true. The NOT reverse the result, returns true if the result is false, or false if the result is true. Here we have x is negative and y is positive. We have a true. If we use the NOT statement, we get a false. So we started by logical operators and we have 3 of them. Now we have value keywords. There are 3 Python keywords that are used as values. So we have the false and true, which are Boolean values and the result of comparison operations, as we have in here. So we have the true and we have the false. We have the none, which represents a null value. For example, if we put z equals to none and we print z, we get a none, which is a null value. We have also the import keywords. The import is used to import a module, from to import specific parts of a module, and as is to create an alias. For example, if you want to import numpy, we write import numpy and we give it a name, which is np, which is much more easier to use in programs. So this is an alias for numpy. If you want to import specific parts of a module, for example, the sign function from the math module, we use from math import sign. Okay, so we imported a specific part or function from our module math. Now we have exception handling keywords. We have 3 of them. We have except, used with exceptions, what to do when exception occur, raise to raise an exception, and try to make a try except statement. For the syntax, we have try, two dots, and we write here our statements. For example, value is positive, except value is not positive, we write value is not defined. For example, because here in our example, we don't have the value defined. This is just a small example about exceptions. So we write that we have value is not defined. We have also another example. Okay, so for example, we write a number. Okay, enter number, for example, 6. Okay, so if x is negative, raise exception, no negative values are allowed. Okay, here we have positive, nothing is raised or no exception is made. But if we run that again, so we write -6, and here we have exception, no negative values are allowed. Okay, so here we have the exception handling keywords. So we have 3 of them, and these are their syntaxes. Now we have the assert keyword, which is used for debugging, and it helps us to find bugs and to check if our assumptions are true. It's followed by a condition, and if the condition is true, nothing happens, but if the condition is false, assertion error is raised. For example, here we define x as true. Okay, so we write assert x is false, we have assertion error. Okay, so this says that our x does not have the right value. Okay, but if we write assert x is true, we don't have an error. Okay, so we call this an assertion error, which helps us to find bugs in our program. Now we have the control flow keywords, where we have also 3 of them used in conditional statements. Okay, for example, we have val equals to 10. We define a variable. We use if by itself alone if we have only one statement. For example, if you want to check if x is positive, 2 dots, we write print positive. Okay, if we have two, for example, classes, whether positive or negative, we use if and else. Okay, so we write if the condition, 2 dots, we write positive, else we write print negative, for example. Okay, but if we have more than 2, okay, so we have, for example, x positive, x negative, and we have other values, for example, x is null, x is complex, etc. So we use elif. Okay, so we use if condition, we have here another condition, elif, and we have else. Okay, else, for example, print others, right? So we have if, elif, and else. These are control flow keywords. Now we have the break statement, which is used inside for and while loops to break out of a loop. For example, here we define I equals to 0. We use the break statement if we reach the value 5. Okay, for example, we write that for I in range 10, if I equals to 5, break. Okay, we print I. If we don't use this statement, okay, we are going to print all the values. Okay, but using the break statement, we have x equals to 5, so we break, we get out of the for loop. Okay, we have also the class keyword, which is used to define a new class. Okay, classes are very used in Python, so knowing the concepts of object-oriented programming in Python is a must. And we use the class statement to define a new class. For example, class, we define the name of the class as number, and we initialize our number with value. Okay, so we use here a function to initialize the class by value. Okay, run that. So create num equals to num4. We create an object, okay, an object as a number. We give it a value of 4, okay. To print this value, we use num.value and we get this value of 4. Okay, so this is the class keyword which is used to define classes in Python. We have also the continue keyword which is used inside also for and while loops to continue to the next iteration of the loop. Here we have the break to break out of the loop if we reach the value, but the continue to continue to the next iteration of the loop, which means that, for example, if we use the same code here, we have 0, 1, 2, 3, 4. When it reaches to 5, it goes directly to 6. Okay, we don't print the value of 5. Okay, for example, if we don't use the condition, we have 0, 1 to 5. Okay, but if we use this condition, when we get the value of 5, we don't display the 5. We continue directly to the next value, which is 6. Okay, we have also def, which is used to define a function. Okay, as we did in here, we have def to define a function inside the class, and we have here small example def. We write here the name of the function, and here we write our arguments. Okay, for the statements, they can be written inside the function. We run that and we run our function. Okay, we call it to display, for example, the number of 2. The value is 2. Okay, we have also the del keyword, which is used to delete the reference to an object. Since everything in Python is an object, so the del function or the del keyword is very used to delete these kind of objects or the references. For example, we have x equals to 10. We call del x. So we have deleted the reference of the object or the reference to the object. When we print x, we have name x is not defined because we have deleted using the del keyword. Finally, is used in block of code with exceptions to close up resources. So this block will be executed no matter if there is an exception or not. Okay, for example, we have here the syntax as previously. So we have here the first part, we have the try except block, we have the else, other exceptions, finally, which is the last statement in our try except block, and this block will be executed no matter if there is an exception or not. We run that. So we have here x is not defined, okay, and continue is not displayed, okay, because we have the first exception and we printed the first statement, but for finally it is always displayed, okay, whether we have an exception or not in our exception handling block. The statement that we are going to put in finally is always displayed. The for, which is used for looping when we know the number of times you want to loop. As you can see here, the range 10, so we want to loop for 10 times. Okay, when we know the number of times you want to loop, okay, the number of iterations, we use the for loop. Okay, so this is the syntax for I in the range 10, we print I, for example, okay, from 0 to 9. Global keyword is used to declare that a variable inside the function is global. Okay, for example, we define a function, we define global variable, which is y, and we give it a value. Okay, we call the function and we print y. As you can see here, even if we have defined y inside the function, normally it is a local variable and it is only, or it belongs to this function, but since we have used global keyword. So we have written global y. When we call, or when we want to print the value y inside the function, it will be printed because it is a global variable. We have also the in keyword, which is used to test if a sequence, list, tuple, string, etc. contains a value. For example, we have my list. We have a list here, and we want to test if our value is in our list. So we write if x in my list, print OK. Okay, so x equals to 1. If x in my list, print OK. So the in keyword is used to test if a sequence contains a value. So here our sequence, which is my list, contains the value x, which is equals to 1. We have is keyword used for testing object identity. So we have here two objects. We have x is a list, y is a list. As you can see here, x is the same as y. And we call a equals to x. So print x is a. A is not defined, so we have to run that. True. But if we write x is y, even though we have 1, 2, 1, 2, we have the same list, but it is false because they are not the same object. Okay, we don't have object identity. So x is a, we have true. We have the lambda keyword, which is used to create an anonymous function. Okay, an anonymous function, sorry. So we have f equals to, this is the syntax, lambda x to x plus 1. So we increment the value of x by 1. Okay, so we run, and if you call f to 1, we have 2. Okay, for example, if we call f of 5, we'll have 6. So f equals to lambda, we put here the value of 6, and it will give us 5, and give us 5 plus 1, which is equals to 6. We have the non-local keyword, which is used to declare that a variable inside a nested function is not local to it. Nested function is a function inside a function. Okay, so we have function inside the function, and we use the non-local keyword to declare that this variable inside this function is not local to it. Okay, if we run that, for example, print. So we have the first function, we declare our variable. We have the second function, which is inside our function. We declare this variable as non-local to this function. We give it a value. We call the function, the second function, inside the first function, and we print the value. For example, we will get the value of 2. Since we have declared that z is non-local to this nested function. We have the pass keyword, a null statement that will do nothing. Okay, for example, we have here x equals to 10, y equals to minus 6. If x equals to y or greater than y, pass. Okay, the program will do nothing, it will just pass. We have a return used to exit a function and return a value. Okay, so we define our function hello. We declare a variable x, a local variable to this function, and we want to return this value that are assigned to x. So when we call our function, the function will return to us the value given inside the local variable. Okay, so return used to exit the function and return a value. Okay, so we return the value of x. We have while, which is used for looping. The for loop, we use the for loop when we know the number of iterations, but the while loop will execute as many number as iterations it requires, as long as this condition is true. Okay, so here we write j equals to 10, we give it the condition, Okay, while j is positive, we print j, and here we decrement by 1. Okay, for example, if we decrement by 2, okay, so 10, 8, 6, 4, 2, then we have 2 minus 2, which is equals to 0, and while j is, so we have here j is not strictly positive, we stop our iteration. We have also the with keyword, which mostly used for file handling, okay, with this following syntax. For example, I have a file which is called cars, which is a CSV file, and we want to open this file in a read mode. So we write with open cars.csv, comma, read as f. So print f.read. Here we are going to display the content of our file using the with statement. Sorry, the with keyword. Finally, we have the yield keyword, which is used like a return, but the function will return a generator. So here we have function, okay, we have a function, and we will have, in the place of return, we will have the yield keyword, and we will return a generator. We are going to talk about one of the most important things in Python, which is testing. In general, when programming, there are some instructions that we want to execute in some circumstances, while others will be made in other cases. Because for the purpose of a program is to solve a specific problem. So when writing your instructions, there are some conditions that you have to respect. So testing is very important in every program, in every programming languages. So the program with the if statement evaluates the condition and will execute statements only if the condition is true. The if statement in Python is a substitute of the switch or case statements found in other languages. In Python, there is only one test instruction that can be declined in 3 forms. The first one is one-line if statement. For example, if we define two variables, a and b, and we want to test if a is greater than b. So we say that print a is greater than b. If you want to know more about operators, we have made a video last week about operators that you can check on the link in this video. The second statement is using if and else. But before doing that, let us check the syntax of the if statement. So we write if, we write our condition, we have two dots, then we press enter. So Python directly gives us this syntax. Okay, as you can see, we have space between the beginning of the line and the print statement, which is 1, 2, 3, 4. So if we don't respect this space, we see the print is in red color, right? So we have 1, 2, 3, 4, or you can directly go to here and press the enter key. Okay, so Python gives us directly the required syntax for the if statement. But if we write another statement in the same line as the if statement, for example, we write print. So you have passed the test, okay? You have passed the test. We see that we have the two instructions are executed, okay? The first one, it is inside the block or the if statement block, and the second one is outside our block. So here we don't have a condition. It is a statement executed in parallel with the if statement. Now we have the other one, which is the most used, is the if else. So we write if A, for example, is less than B, print A is less than B. Okay, we come back to the beginning of the line, we write else, two dots, we press enter, print A is greater than B. Okay, A is greater than B. But as you can see, if we write statement, another sentence at the beginning of the line, it will be executed in parallel with all this block. Okay, so we will have the two statements printed. Okay, for the else also we have the same syntax. Okay, so we have else, two dots, we press enter, we get this space, or you can count like 1 2 3 4. Okay, if we have, for example, 1 2 3, we have print is in red. The third one is when we have more than two conditions. Okay, for example, if we have if A is equal to B, for example, print A is equal to B. Okay, elif, okay, so we write elif, then we need to write a condition. As you can see here for else, even though we don't write a condition, but it will be executed because we only evaluate the condition where we have if. Okay, so if A less than B, else print A is greater than B. If A equals to B, we have the condition. Elif, we have to write our condition. A is less than B, print A is less than B, right? Else, okay, else we don't write a condition, print A is greater than B, A is greater than B, right? So write A is greater than B. Here also, if we write a statement at the beginning of the line and at the end of the if else block, so we write you have passed the test. Okay, so we have here a statement that is executed in parallel to our test block. Okay, we have also what we call nested if statement. Okay, nested if statement, it is an if statement inside an if statement. Okay, so we write, for example, A equals to, for example, or we write C equals to 10. Okay, we check if, for example, C is positive. Okay, we write print C is positive. Okay, else print C is negative. Okay, but we want also to check if C is even or odd. Okay, for example, we can write here another statement, if C modulus 2 between parentheses equals to 0. Okay, so we write print C is positive, C is even, because we have here C is positive. Else print C is odd, right? Run that. C is positive and C is even. So when we have an if statement inside another if statement, we call this nested if statement. We are going to talk about loops in Python. Loops are very useful in programming since they allow us to save time, to save line of codes, which means that you are going to write one single statement which repeats itself and do all the job for you. For example, if you want to print a statement like 10 times or 20 times, you could write print statement 10 times, or you could use a for loop or a while loop. So in Python, we have only two types of loops. We have the for loop and the while loop. For loop is used when we know the number of iterations. We can use the for loop, for example, to loop or to iterate in a range of numbers using the range function when we're dealing with numbers, or you can iterate over a sequence, like for example a list, a set, a dictionary, etc. The syntax of the for loop is the following. So you have to write for, you declare your variable in, because we have said that it has to be in a range of numbers, or you can iterate over a sequence. So you write for variable in, for example, we define range. The range function is defined as the following. You have the beginning, you can start from 0 by default, or you can start from 1 or any number that you want. Then we have the end. So for example, you want to go from 1, let's say, to 20, for example. And the third part is about how much you want to increment. By default, it is 1. For example, if we write range 20, it will start from 0 to 20 and it will increment by 1. But here, we can, for example, use an increment of 2. Okay? You have to add colon and press enter. The number of spaces between the beginning of the line and the correct statement inside the for loop is 4 spaces. So you have to count 1, 2, 3, and 4. Okay? Then you write your statement. For example, you have to write print our variable, for example, and run that. Okay? So you start from 1 to 19, because 17 plus 2 is 19, 19 plus 2 is 21, which is more than 20. Okay, so we count from 1 to 19. Or for example, you can define your sequence like this. For example, you can define sequence, for example, a list. Write 1, for example, 2, and 3, for example. Okay, we execute that, and you can write, for example, 4. Same thing, you can declare your variable and you can call it, and you give it any name that you want. So for element in sequence, press enter, print element. Okay, and as you can see here, when we do the statement, by default it is printed line by line. So each variable or each element is printed in a separated line or in a single line. So as we have said, for is used when we know the number of iterations. The while loop is used when we don't know the number of iterations, or more precisely, when we have satisfied condition. Okay, so for example, you can define variable I equals to 1, okay, and while, for example, while I is less than 10, okay, you print I. If we just let it like this, it will print forever because I, which is equals to 1, is always less than 10. So we have to add an incrementer in here. So I plus equals to 1. Right. So we start from 1, 2, 3, 4 until it reaches 9. So 9 plus 1, it is 10. So the condition is not true anymore, not satisfied, which means that we get out of the while loop. We have also the break statement, which is used to get out of the loop. For example, here we have while I less than 10, so we have to wait until I equals to 10 to get out of the loop. So for the break statement, we use it as the following. So we write, for example, for I or j in range, let's say 10, okay, if j equals to 5, break, and here we print the j. So run, you have 0, 1, 2, 3, 4, but when j it is equals to 5, we get out of the loop. So the break statement is used to get out of the for loop. The continue statement is used to skip an iteration. So here we have get out of the loop, but here we only skip it. So for example, for a in range 10, if k equals to 5, you continue, which means that we don't print our value. So we have 0, 1, 2, 3, 4, 5. If k equals to 5, we continue. We don't print this value. So we have 0, 1, 2, 3, 4, and we skip it directly. Then we print 6, 6, 7, 8, 9. So this is for the continue statement. We can also use the else statement with loops. For example, we have here for z in the range 10, we print z. Once we printed all the values, which means that we are at the end of the sequence, we say else print no more iterations, for example, no more iterations, okay? So 0, 1 until 9. Once we reached the end of the sequence, we print no more iterations. So the else statement is not only used with the if, but it can also be used with the for loop. We have also the nested loops, which means that we use a for loop inside another for loop. For example, we have for x in the range 5 and for y in range 2. For example, we print the multiplication, print x times y, for example. So we have x in the range 5, so we have 0 times 0 is 0, 0 times 0 is 0, and we continue until the end of the sequence. For example, you can start from 1 to avoid 0, and also here you can start by 1. Okay, so we have 1 times 1 equals to 1, 1 times 2, 3, and 4. We are going to talk about data structures in Python. And why are data structures very important in Python as in any other programming language? First of all, we start by the definition. Data structure is a way of collecting, organizing, and storing data in a way that we can access and perform operations on this data efficiently. As we are dealing with data science, data analysis, big data, data has to be organized and it has to be in specific memories locations and in specific, for example, lists, dictionaries, sets, depending on your programs and depending on the tasks and the problems that you are resolving. This data needs to have a form that allows you to understand it rapidly and to work with it efficiently. We have two types of data structures in Python. We have the inbuilt data structures, which are built inside our programs and in Python. And we have also the user-defined data structures. Data structures that you are going to define in your program and you are going to implement these functions or classes depending on your problems. For the inbuilt, we have lists, tuples, dictionaries, and sets. User-defined data structures, we have tree, graph, stack, linked list, and queue. Inbuilt data structures can be mutable or immutable. Mutable means that you can modify it. You can add, you can insert, you can remove, you can delete, depending on what you are looking for and what are using these data structures for. For the mutable, we have lists, dictionaries, and sets. Immutable data structures means that they cannot be modified. And we have only one type, which is called tuples. A list is defined as an ordered collection of items. It is the most used among Python data structures. It is changeable, which means that we can add, we can remove, and we can modify it during our programming task. It allows duplicates, and lists can be nested, which means that we can have a list inside another list. Okay, so the items inside the list can be also lists. A tuple is defined as an ordered collection of items, as a list, but it cannot be modified. Once you define a tuple, it will stay as it is in all your process of programming. And tuples are preferred over the lists when the user does not want the data to be modified. Dictionaries are used to store data values in key, comma, value pairs. It is a collection which is ordered and they are changeable, but they do not allow duplicates. As we have said, lists allow duplicates in your program, but it is not the case for the dictionaries. A set is defined as a unique collection of unique elements that do not follow a specific order, which means that inside a set, for example, we cannot find two elements that are the same. For example, in a list, you can have, for example, the element number 1 is letter E, the second is letter E, the third one is letter E. But inside a set, you can only have one letter. For example, E or I or T. So sets allow you to have unique elements, which means that you cannot have a lot of elements that are the same. For the user-defined data structures, we start by a linked list, which is a linear structure that is represented by a collection of nodes, and each node is linked to the other node by using a pointer. Linked lists are built in Python using classes. So object-oriented programming will allow you to build this kind of data structures, which is very powerful in very specific cases. A stack is also a linear structure that allows data to be inserted and removed from the same end. As you can see from this image, the last element that is added to the list is the first element that is going to be out, which means that last in, first out. We have also the queue, which is a linear structure as a stack, but the only difference here is that the first element that gets in is the first element that gets out. Okay, so it allows insertion of elements from one end and deletion from the other end. We have also trees, which are very useful and are applied in, for example, machine learning. You can apply binary trees in a lot of examples using classes and object-oriented programming. A tree is a nonlinear but a hierarchical data structure. The topmost node is known as a root node. Each node contains some data, and data can be of any type. Finally, we have the graph. A graph is a common data structure that consists of a finite set of nodes or vertices and a set of edges connecting them.
We are going to talk about one of the most used data structures in Python, which is lists. A list is defined as an ordered collection of items, which means that each item has its own index, and it can be called or accessed using these indices. As I said, it is the most used among Python data structures. It is changeable, which means that we can add, we can delete or remove items from the list. It allows duplicates, which means that we can have more than one word or one number in the list. And also lists can be nested, which means that we can have the items inside the list as lists. To start, we can create an empty list. For example, we can start by my list equals to, and you add square brackets like that. So when you want to know the type of your data, you can just write type and it gives you lists. You can have here note. We cannot use the keyword list as the name of the list. Okay, we cannot use, for example, here list equals to this empty list, for example, because it will generate an error. You can also create an empty list using directly my list, we call it 2 equals to list, the function, the built-in function list. Okay, so when you print my list 2, it will give you an empty list. As we have said here, list cannot be used
as the name of the list because we can use it to create another list. Here we have the function, and also to create not only an empty function, but we can have some items in our list. For example, my list 3 equals to, you can write list, you have here the parentheses, and you also add another parentheses. Okay, inside the list we can have different data types. Okay, so you can write a comment here, we can have different data types inside list. For example, we can have string, okay, 1, we can have an integer 2, we can have float 0.5, we can have a boolean true, for example, or false. We can have also another list, for example, this, for example, is a list, for example, okay, etc. So if you're gonna run that, you have type of my list 3, it is a list, okay. And here in Jupyter Notebook, you don't need to write, for example, print my list 3, okay. You can directly have my list 3 like that, and it will print it to you. Okay, so we have the different data types inside our list. As we have said, we can have the item as another list. You can have boolean, you can have float, integer, you can have string, etc. To know the length of your list, you use the function len. So len my list 3 will give you 6. So 1, 2, 3, 4, 5, and the whole list is considered as one item. Okay. If you want to know the length of the empty list, for example, my list 2, you have 0 because it is an empty list. An important thing to do before starting modifying or working with your list is to create a copy. So you can write list copy, for example, okay, equals to my list 3 dot copy. Okay, so if you are going to print that, you have your function. Sorry, we use the function, so you have to add the parentheses. You use the copy function to copy your list if you want to modify it in your program, because if you are going to modify this list directly, it will change directly the memory location of your data. So for example, if you want to change 1 to 2, it will directly change it from your list. But here, since you have a copy, you can work with your copy, you can add, you can remove, you can do all what you want in this list. But if you want to call the first one, you will have it unchanged. Okay, so this is a very important thing to do if you want to work with your list in your program. To access your elements, for example, the element number, first element, you start from 0. Okay, you start from 0. So this is indexing, right? Call this indexing. Sorry. Call this indexing, right? If you want to, for example, access the last element, so this list, we can use list
copy, for example, -1. Okay, so -1 gives you the last element. So 0 gives you the first element. So 0 gives you the first element of the list, and -1 gives you the last element of the list. Okay, so just copy that. We have here -1 gives you the last element of your list. Okay, and if you want to access, for example, from 1 to false, you can directly start from 0, 1, 2, 3, 4. Okay, so you write list from 0 to 5. Sorry, list copy. I'm sorry, it is not defined. Opa. List copy, right? So as I said, from 0, 1, 2, 3, 4. I have written here 5 because it accesses the element 5 minus 1. Okay, so it starts from 0 to 5 minus 1, which means that to 4. So 0, 1, 2, 3, 4. Okay, and for example, if you want to access 1, then 3.5, then false, you can use here list copy, and you increment by 2. Okay, so you increment by 2, so 1, 3.5, and false. Okay, this is slicing, we call this slicing, and here we increment by 2. We increment by 2. Okay, so this is about slicing and dicing and incrementing by different value that you want. So you start from, this is the start, this is the end, so we'll access the element, this element -1, and here the value that you want to increment. For example, you want to increment by 2, by 1. As you can see here, by default it is 1. Okay, so this is about accessing your elements inside the list. For example, if we want to loop over the list, for example, to know the elements of the list, we can use the for loop for element in what is called list copy. Okay, list copy. So print element, print. So it will print for you the elements line by line. So this is for looping through a list, for example. Okay, so we use the for loop to access the element of our list. Sorry. And if you want to change, for example, the first element or the second element, so we have list copy, right? List copy, we have 2 equals 2, for example, we change it to string. Okay, right? And if you are going to implement that or to print that, you will have 1, 2, okay, 3, 4, 5. Okay, if you want to change it, for example, from 2, so from this one to, so 0, 1, 2, 3, 4. So we write from 2 to 5, for example, list copy, for example, from 2 to 5 equals 2, for example, we write 3, 4, 5, 3, 4, and 5, for example. Okay, and if we print that list copy, so you will have the values changed. Okay, 1, 2, 3, 4, 5. So this is about changing the elements of your list. For example, if we want to remove this element, so we can write list copy, okay, dot pop, and we have the index number 5. Right, so it has removed this list for us. If we check, we find that the list does not exist anymore in our list. Okay, so this is to remove an item, to remove an item using index. Okay, so using index, we can do it also by using the del function. So del list copy, okay, and we want to remove the fourth element, for example, so 0 1 2 3 4. Right, so list copy, and we have only the 4 elements, 1 2 3 4. Okay, we can also remove using we can also remove using the remove function. So you have this list copy dot remove, for example, we say 3. Okay, right, list copy, and we have 1 2 4. Okay, so we have 3 is removed and 5 also is removed. So here we remove using the name of the item. Okay, here by the index, here by the index, and here by using directly the name of your element or your item. If you want, for example, to add elements, so here we have removing, and here we will add. So add elements using the append function. So list copy dot append, and you write the word of, for example, that you want to add. So here we have removed 5, we will add 5. Okay, right, if we copy that fast, we have 1 2 4 5. We have removed the number 3, which is in the position 0 1 2. To add the 3 in its position, I mean in its first position, we can use the insert function. So we write list copy dot insert, and we set that position number 2, and the value is 3. Okay, so if we're gonna run that, we'll have 1 2 3 4 5. Okay, and also if we want to add more than one element to our list, for example, we have add list equals to, for example, 6 and 7, we can use the extend function. So you have list copy dot extend, and you put add list. Okay, so if you are going to print that list copy, we will have the elements added. So we have 1 2 3 4 5 6 and 7. And we can also, so here we add more than one element. So here we have add an element by index and now here we add an element automatically to the end of the list. Okay, and we can also sort our list. So list copy dot sort. So if you're gonna put that, for example, list copy equals to, if you want to print that, it will order it depending on the letters. Okay, so we have F, O, S, T, and T. All right. And finally, if you want to delete your entire list, you can use del and list copy, and this will directly delete the entire list for you. Or you can, if you want to clear it, you can use this. So list copy dot clear, and this will return to you list copy with no items, which means that it will be an empty list. We are going to talk about tuples, which are defined as an ordered collection of items. Tuples support all the data types as items, which means that we can have strings, we can have integers, we can have boolean, etc. Tuples, they cannot modify it. As we have seen for lists, they are changeable and they can be modified. So in a list, we can add, we can remove, we can extend the list, etc. But this is not the case for the tuples. So tuples are preferred over the lists when the user does not want the data to be modified. To create a tuple, we use the parentheses. So we call it tuple 1 equals to, you open the parentheses and you write, for example, 1, 2, and 3, for example. Okay, so we have here a tuple that contains items as strings. To know your data type tuple 1 and you get a tuple. To know the length of the tuple, it is the same as lists. We use the len function. So len tuple 1, and it gives you number 3. To access the first element of your tuple, we write tuple 1 square brackets 0, and we run that. If you want to access the last element, we write -1. Sorry, tuple 1. So here we access the last element of our tuple. So this one is called indexing. This one also is reverse indexing. And we have also slicing. So if you want to access, for example, the first 2 elements, you can write tuple 1 and you start from 0 to 2. Okay, so this is about creating a tuple, the type function, the length function, indexing, and slicing. So as we have said, tuples are unchangeable, which means that they cannot modify it. For example, if you want to modify the first element, tuple 0, and you can change it, for example, to 0, says that tuple object that does not support item assignment. One method to do that is to convert your tuple to a list. So tuple converted equals to list tuple 1, run, and here, for example, you can change this one. So we write tuple converted. Okay, we have 0, which is equals to 0, right?
and we are going to modify this one into our tuple. Okay, tuple using the tuple function. So this is converting a tuple into a list. So converting tuple into a list. Then we add our elements and converting the list to a tuple. Okay, so here converting a list into a tuple. All right. So this is one way. If you want to modify, for example, your tuple during your program assignment, so you can just convert the tuple to a list, modify it, then convert the tuple into the list into a tuple again. So as we have said, tuples as list, they allow duplicates. For example, we can create tuple 2, right? We write for example 1 1 1, for example 3 4, etc. So here we have 3 ones. Okay, if we run that, we will get no error because tuples allow duplicates. So we have here tuples allow duplicates. Okay, duplicates, sorry. So we have they allow duplicates, and also we can access the elements of our tuple using the for loop. Okay, so for element, okay, in tuple 2, okay, print element. So it will print for us all the elements inside the tuple line by line. And also, as we have said, tuples support different data types. So if we create tuple 3 equals to, for example, today, okay, and here we have 1, here we have 3.45, here we have false, and we can have also another tuple inside. So 1, 2, 3, and 4. Okay, run. So tuple 3 will give us these different elements. So we can have a tuple inside a tuple. Can also have a list inside a tuple, which means that tuples allow different data types. Okay, so tuples allow different data types. Okay, one way also for creating tuples is using the tuple function, as we have said earlier, but here we use the double parentheses. So we create parentheses first time and another time. Okay, so we create 2 again 1, for example. Okay, 2 again 1. Okay, so we create that, we call it tuple number 4. Okay, so tuple 4, we have its type, it is a tuple. Okay, so write type will get a tuple. Okay, but if we only use one parenthesis, okay, so tuple expected at most one argument got 3. Okay, so it will generate for us an error. So here we have double parentheses. Just be careful about that when you want to create tuple directly using the tuple function. Okay, and if you want to print that tuple 4, Also, if you want to create a one element tuple, so call it tuple 5, we write parentheses like that, and we create, for example, element, we call it element, and we have to add a comma. Okay, right. So if we write type tuple 5, we'll get a tuple. But if we remove the comma, okay, it is a string. Okay, so be careful about that. If you want to create a one element tuple, you have to add the comma. Okay, tuple. You can also create another tuple, call it tuple 6, which is equals to, for example, tuple 3, for example, plus tuple 5. Okay, tuple 3, okay, plus tuple 5. Okay, so this is about joining tuples. Okay, this is joining or adding tuples. Okay, and the one function that we use when we are dealing with tuples, for example, if you have tuple 7, okay, equals to, for example, 1 2 3 2 3 4, sorry, 4, for example, 5 9 10 7 3, for example. Okay, so this is tuple 7. If you want to count the number of, for example, of 2's or of 3's in your tuple, you can use the count function. So we write tuple 7 dot count, for example, 2. So we have 2 2's in our tuple. For example, if we write tuple 7 dot count 3, it will give you 3. So we have 1 2 and 3. So we have 3 3's. We are going to talk about another type of data structures, which is sets. A set is defined as a unique collection of unique elements that do not follow a specific order, which means that we don't use indices as lists and tuples in sets. It is iterable, which means that we can use a loop to print our elements inside the set. It is mutable, which means that we can add, we can remove, and has no duplicates elements. So it does not allow to have duplicates inside itself. Sets are highly useful to efficiently remove duplicate values from a collection like a list. As we have seen, in a list, you can have duplicates or more than 2 elements inside a list. So to know the unique elements of this sequence, we can use a set and convert it. Thus, we will get out of the duplicates. Sets also are useful to perform common math operations like unions and intersections. To create a set, we use the curly brackets. So we call, for example, set1 equals to, for example, we get a set of numbers. So 1, 2, for example, 3. Okay, use type function to know the type of your data structure, so it gives you a set. We use the len to find the length of the set, which is 3. Set 1 0. Set object is not subscriptable. Okay, so as we have said, we don't have index for this element or this one or that element. Okay, also it is unchangeable, which means that, for example, if you want to change this element to, I don't know, for example, we call it 4, we cannot do that. Okay, because this set do not support item assignment. Okay, and also if you want to create an empty set, we cannot use directly the curly brackets as we do for the list. For example, we use directly the square brackets, or in tuples we use the parentheses, but here if we use directly the curly brackets, we get the type as a dictionary. Okay, so if you want to create an empty set, you use directly the set function. Okay, so write set, and here we have the type, which is a set. Okay, and the length, which is an empty set, so it will give us 0 as the length. Okay, so this is about creating sets. We said that they are unordered, which means that we don't have indices, and also we use the type and the length function as lists and sets and tuples, sorry. So for example, if you want to create a list, sorry, we cannot use the keyword list1 equals to, for example, 1 2 3 1 1 1 1 3 4 5, for example. Okay, and you want to know the number of unique elements inside this list, so we can use this set list equals to set list1. Okay, so if we want to print the unique elements of this list, we will get directly 1 2 3 4 and 5, so it will get out of the duplicates. Okay, so this is one way to know the number of unique or the unique elements inside the sequence. So we are going to copy that, for example, set1. Okay, and we want to loop through this set. So for I in set1, we print the I 1 2 3. So as tuples and lists, we can use the for loop to iterate through the sequence or over the sequence and print our elements. So as we have said, we can have any data type if we want that we want inside the set. So we have, for example, 1 2 3 so 1 2.5 false, true. We can have, for example, another tuple. Okay, so for example 1 7. Okay, so it will create this set type set4. So we have a set, but if we try to have another set, for example set1 equals to, we try to copy that, copy first, and we change this to list, so it will generate for us an error. Okay, and also if we change it to set, call it 6. Okay, so call it set, and we change it this one, we'll get also an error, so we can only have a tuple inside set. Okay, so this is about the data types inside the set. For example, as we have created in here, so I will just copy that, copy, paste. Okay, so we call it set1 and we call this set2 equals to, for example, 1 2 and 3. Okay, for example, if we want to add an element inside the set1, so we just can write set1, okay, dot add. For example, we add number 4. Okay, and we have here set1, it will be added anywhere because we don't have an index. Okay, so it will automatically add it to the first element that we have. If we want to try something else, so set1 dot add 5, for example, okay, and we print set1, it will add it directly to the first element, okay. As we have seen in the lists, when we use, for example, the append, it will add it, we add to the last element of the list, so the last index. But as you can see in here, it will add it to the first, so it will put it from the left to the right, okay. And if you want, for example, to add all this set to this set, we can use the update. So we write set1 dot update, update, and we write set2, okay. So it will update set2 into set1, okay. So for example, we can also use the union function. So we create set3 equals to, for example, 4, 5, 6, okay, and we do set1 dot union, so which means that we add the set3 into set1, okay. So we have 1, 2, 3, 4, 5, 5, 4, 1, 3, 2, okay, 5, 4, 1, 3, 2, 1, 2, 3, and we have added the 4, 5, and 6 into our set1, for example. Now if we want to remove elements, okay, for example, we want to remove I don't know, for example 3, okay, so we write set1 dot remove, and we write 3, okay. So if we print set1, it will give us 1, 2, 3, oops, sorry, because I had to, normally it would directly work, wait, set1 dot remove 3, so it does not exist. And when we print set1, okay, so right here set1 equals to, so if you want to print set1, okay, 1, 2, 3, 4, 5, 6, and so we have removed 3. Now we want to remove, for example, 4, okay. So set1, it will have 1, 2, 3, 4, 5, so 4, 5, 4, 1, 2, sorry. So we have removed the 4, and we remain by this last set. So this using the remove, and as we have said, set1 dot remove 3, okay, it will generate for us an error if 3 does not exist, okay. But we can use the discard, for example, we will remove 1, okay, so we say that set1 dot discard, okay, and we write 1, okay. So 1 is removed, has been removed. But here, if we try to remove 1 again using the discard function, okay, discard, and we write 1, it will not raise an error for us, okay. So discard and remove do exactly the same thing. Just remove if the element does not exist inside the list, it will create for us an error. Whereas discard, it will not generate an error. So if we replace it by remove, so we'll have an error, okay. This is the main difference between remove and discard. And we can also use the pop function, okay, set1 dot pop, and it will remove for us 5, okay. Since we don't have an index for any element inside our set, so pop, it will not, for example, like in a list, it will by default remove the last element of the list, okay, because we have the index of the last element. But here, as you can see, 5 is not the last element, but it has been removed by the pop. So it will choose any element or any item inside the set and it will remove it. Okay, because we don't use indices. If you want to, for example, to clear a set, okay, use set1 dot clear, and here we will get set with no items. Okay, so length of set1 is 0, and we can also delete using the del function completely the set. So if you call set1, it will say name set1 is not defined. So this is to clear, to remove all the items inside the set and to get an empty set. But the del function, it will directly remove it from your program. So when you try to call that, it will say to you that it is not defined. So for example, if we create my set, create my set1, for example, equals to let's say 1, 2, 3, 4. Okay, where are that? We call my set2 equals to, for example, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so we can do the intersection. For example, if we want to know the duplicates inside the two lists, so the elements that are present in here and in here, we can use the intersection function. Okay, so we write, for example, my set2 dot intersection my set1. Okay, so we have the intersection between set2 and set1 is 1, 2, 3, 4. Okay, these are the elements that are present in both the sets. But if we use symmetric difference, okay, it will only keep the elements that are not present inside the two lists. Okay, so for example, if we write my set2 dot symmetric difference, okay, symmetric difference my set1, it will give us the elements that are not inside the two lists. So this is mainly union minus the intersection. Okay, so union, it will create 0 to 10 minus the intersection, which is 1, 2, 3, 4. Okay, so it will give us, so symmetric difference will give us the elements that are not present in both sets. Okay, and there is also my set1, for example, set1 dot is subset of my set2, for example, my set2 true. Okay, because my set2 is or contains my set1, so my set1 is a subset of my set2. Okay, we are going to talk about dictionaries. Dictionaries are used to store data values in key value pairs. It is a collection which is ordered, they are changeable, and they do not allow duplicates. Also, dictionaries can be nested, which means that we can have dictionaries as values inside a dictionary. And at the end of this video, we will have a small application which is finding the number of letters inside the sentence and returning an output as a dictionary which contains as keys the letters and as values the number of letters for each key in the sentence. To start, we can create a dictionary using the curly brackets. So we write dict1
equals to curly brackets. Then you have your keys. For example, we write 1, comma, colon 1. Then we will have a comma, we'll have 2, 2, right? We'll have 3 and 3, okay? So we don't put a comma at the end of the last element, okay? So we use the length to find the length of the dictionary, dict 1. We'll have 3 elements, we have 3 pairs. We can use the type function to know the type of our constructor, which is a dict. We can also create an empty dictionary using curly brackets. We'll have a dictionary, and we can have any data type that we want as values in our dictionary. So for example, we call it dict 3, okay, equals to curly brackets, right? And we can put, for example, as key 1, okay, put key 1 equals to float, for example. We put key 2, which is a string. We're gonna put Monday. And the third one, for example, we call it key 3, which is boolean. And also we can have, for example, key 4 as a list, for example, okay? So we can have any data type that we want inside our dictionary, okay? And also we said that dictionaries do not allow duplicates. For example, if we create dict 4, okay, equals to, let's say, I will always put numbers because it's much simpler. 1, 1, okay, 2, for example, 2, and we add another 2 in here, okay? So 2, 2, right? Forgot the comma in here. Run. So once you print that, you see, it removes automatically the duplicates. Okay, so it will print for us only one pair. Thus, we confirm that they do not allow duplicates. So here, for example, we can change. Okay, for example, if you want to change the second element, so we can put it dict 4. Okay, it is called 2. We can change it to, for example, equals to 3. Okay, so we can write dict 4 and it changed the value for us. Okay, we can also add elements. Okay, for example, we can put dict 4 dot update. Okay, so we can write, for example, curly brackets, your key and your value. Okay, sorry, 3. So write dict 4. Okay, so we have 1, 2, 3. As you can see here, it does not allow duplicates for the keys. Okay, but for the values, we can have the same values for all the keys if you want. Okay, so it does not allow duplicates regarding the keys. Okay, we can also add elements using this method. Dict 4, for example, we call it 5 directly, Since it does not exist, it will create it directly for us. Okay, so it will add it directly to the dictionary. Okay, so 1, 2, 3, and 5. Okay, so this is to add elements to our dictionary. For example, if we want to remove, we can use dict for dot, and you can press tab. It will give you all the methods that you can apply to your dictionary. Okay, so we said we can remove an item, so you write pop and you enter your key. So we want to remove 2. Okay, so if we print dict 4, give us 1, 3, 5. Okay, so we can use pop, or if we want directly to remove the last element, we can use dict 4 dot, we press tab, and it gives us the list. So pop item, it will remove directly the last element. So you see 5. So we have here dict 4, it is 1, 3. Okay, now if we want, for example, to clear, or for example we want to copy, dict 4 dot copy. Okay, so we call it dict copy. So the copy function will create for us a copy of the dictionary. Okay, so we have the same dictionary. And if we want to clear this dict copy, okay, dict copy dot clear. So write dict copy, give us 0. Okay, we don't have items inside the dictionary since we have used the clear function. Okay, and if we want to delete it, del dict copy. Once we call that, it does not exist. Okay, because we have deleted the dictionary. So we have seen pop to remove an item, pop item to remove the last item, and we have also, you can also use the del function to remove. For example, we want to remove dict 4, 3. Okay, so you write dict 4 and you write here 3. So once you print dict 4, we only have 1. Okay, so we have added, we have removed, and we have copied, and also we have deleted our dictionary. Okay, so we add elements, dict 4 dot date. So we add, for example, 2, add 3, we add 4, sorry, okay, so dict 4, we have this dictionary. Now if we want to iterate or to loop over this sequence, we can use 3 methods. Okay, so for example we start from for item in dict 4 dot items. So it will give us all the pairs that are present in our dictionary. Okay, so 1, 2, 3, 4. Okay, so this is one method. The second method, if we want to know the keys. Okay, so for key in dict 4 dot keys, print key. Okay, so this one to know the keys in our dictionary. And this is the last one, which is for value in dict for dot values. Okay, print value. Okay, so we have three methods to iterate or to loop over the dictionary. You can use the items, and don't forget the parentheses because it is a function. You have the keys and you have the values. Okay, if you forget one of these functions, you can just print tab, press tab, and it gives to you all the so we have values. We have used update, pop item, pop keys, items. So copy, clear. We didn't use yet get and from keys and set default. Okay, so we start from get. We write, for example, 1. So this is 1 is the same as writing dict for give me the value of the key 1. Okay, so it is the same. So it will call and it will give us the value that corresponds to the key 1, which is 1. Okay, and we have also the from keys. Okay, so from keys it uses two items. So we have the first item, which is a list or a sequence, okay, something that is iterable, and the second one, which is the value. Okay, for example, if we want to create excuse me just a second, so we create here, for example, vowels. Okay, list to create it vowels. Okay, so we have A, we have E, we have U, we have I, we have O. Okay, so for example, okay, so this list of vowels, and we want to create a dictionary that says to us that all these letters are vowels. Okay, we put the first element, which is something iterable, which is a list, so we have an iteration. Then we put here the value vowel. Okay, and we call this vowels dict. Okay, right, once you print vowels dict, so we have A is a vowel, E is a vowel, U is a vowel, I is a vowel, O is a vowel. Okay, so the from keys, it will create for us a dictionary from a list or sequence that is iterable by assigning a value to all its elements. Okay, so it will iterate over the sequence. We have A, we have E, we have U, we have I, we have O. Then it will put for all the keys the same value. Okay, so this is from keys, and we have last one, which is dict for dot press tab, which is set default. Okay, set default will give us, for example, you put here key, we have here, for example, 4. Okay, and you try to change it, you give it 5, for example. Run that, it gives us 4. Set default will give us the value of the key if it exists, or if we don't have, for example, we don't have 5, as you can see here, we have 1, 2, 3, 4. We don't have 5. Okay, so we choose dict 5 dot set default. Okay, give it 5, and we add the value of 5. So since 5 does not exist, dict 4, sorry. So since 5 does not exist, it will create this pair inside the dictionary for us. Okay, 1, 2, 3, 4, 5. Okay, so if the key exists, it will return us its value. If the key does not exist as 5, it will create this pair inside the dictionary. Okay, for example, if we try to do that, set default. Okay, we have 5 and we change it, for example, to 7. It will return for us 5 because it exists. Okay, so write dict 4 and we will have 5. Okay, so now we will have an application about dictionaries which is an exercise that gives us an output the number of letters or the letters as keys and the number of letters present in the string as the numbers, so as values. All right, for example, we can call it this is an example about dictionaries. Okay, so for example, we have t is present 1, twice, 3 times. Okay, so it will give us as a key the t and as value 3. Okay, to do that we have first to create letters, we call it letters dictionary, dict, which is an empty dictionary. Okay, and we will iterate or we will loop over the sequence text, so call it for letter sorry in text. Okay, so we just have an idea about what this is going to be, so we'll count the number of letters in here. Okay, and we'll get an output as a dictionary. So if letter not in, as we have said earlier, letters dot keys will give us the keys of the dictionary. Okay, dot keys, and it is a function. So if it does not exist, the key does not exist, we will create it. So we call it letters dict, and since it is a string, it is a letter, we cannot use the quotes, but we will use the str function to convert it to a string. Okay, str letter, okay, equals to 1. So here we count t does not exist, so we create the key t and we give it the number 1. Okay, else, okay, so we will find the t again, we'll find t again, which is here, but we do already have letters dict and t as a key. So what we are going to do is we are going to increment that by 1. Okay, if it doesn't exist, we create it. If it exists, we add 1. So we run that and we get our dictionary. Okay, letters dict, we give us a dictionary. So we have t is presented 3 times, h once, I 5 times, s 3 times, etc. Okay, so we'll have all the letters that are present in here and the number of times that each letter is presented or is present in the text string. We are going to talk about lists and dictionaries comprehension. List comprehension is used to create a new list
based on the values of an existing list faster and in one line of code. It is faster than processing a list using the for loop. Its syntax is as the following. We have the square brackets, we write our expression, we iterate using the for loop, and we add incantation. Date comprehension is also used for transforming one dictionary into another dictionary. Its syntax is we open the curly brackets, we use the key value pair for a variable in an iterable. To understand that, we are going to start by list comprehension. For example, assume that you have a list. So create list 1. It is an empty list. And you want to create, for example, for element in, let's say, range 10, you want to create the square root of the elements and you want to append them to the list. So you want to create a list of the square values for the element presented in the list for range 10. What you can do is use the list 1.append and you write element square, right? Then you are going to implement, you got to print, your list. Okay, so we have 0, 1, 4, 9, 16, etc. With list comprehension, as we have said here, expression for item in iterable if condition. So for example, let's say we want to create this list. Okay, so we write list 2, we open the square brackets, we write our expression, so element square, okay, for element in range 10. Okay, and if we want to print that, we get our list. It is the same. Okay, so look at here, we have 1, 2 lines of code, and here we have only one line of code. What if we want to create, so we call it list 3, and we want to create a list which contains the square root of the elements, but only the square roots that are even. So we have, for example, the 4, 16, 36, 64. Okay, so here we have to add a condition. We have the if condition. To do so, we created list 3, call it list 3, list 3. So for element in range 10, so we call it if, so element square root is even, so we use the modulus 2, right, equals to 0, we append. All right, else pass. Okay, we run that. Name element, name element, so we have 0, 4, 16, 36, 64. So we have here 4 lines or 5 lines of code. Okay, 1, 2, 3, 4, 5. Let's assume that we can omit this one. So we have 3 lines. But we using the list comprehension, we just write list, for example, squared equals to, we set our expression, it is the square roots, element square, the iterable for element, we said range 10, so this is our existing list, and we add the condition. if we said element is an even modulus 2 equals to 0, right? And we are going to implement that list squared. Okay, so it is the same. As you see here, we have only one line of code, and we did not use the 3 lines of code. Okay, so it is faster, the syntax is simpler. I mean, you can understand exactly what we have did in here, and you will gain time. Okay, so this is one example for list comprehension. Let's say, for example, we want to use it using strings. Okay, so we create, for example, list string. Okay, we call it, for example, 1, 2, for example, 3, 4. Okay, for example, we want to create a list. Okay, we call it list 4. Okay, which contains the strings that contain the letter O. Okay, so we write our expression. So element, or how to call it, noun or number. Okay, number 4, number in list string. Okay, if, let's say, O in number, right? And we print list 4. So here we say our expression is the number, our iterable is for the number in our list, if the number contains in its elements the letter O. So we have 1, 2, and 4. 3, 5, 6 are excluded. Okay, and for example, we use not in number, so we'll get the remaining 3, 5, and 6. Okay, we can also use that, for example, if we want to use 2 for loops. Okay, so we have nested for loop. We create, for example, vector 1 contains 1, 2. Okay, vector 2 which contains 3 and 4. Okay, and we want to create the pairs, so we have 1, 3, 1, 4. Okay, 2, 3, 2, 4, for example. So to do that, we have to write, we have to create, for example, pairs. Okay, we call it pairs equals to, for example, x and y, let's say coordinates or pairs for x in vector 1. We don't write and, we add another for loop for y in vector 2. Okay, so we have created pairs, the possible pairs between these two vectors. So we have 1, 3, 1, 4, 2, 3, 2, 4. Okay, so nested for loops can be used for list comprehension. So we have 4x in vector 1 and for y in vector 2. Okay, so we have 2 iterables in here. We can also use, for example, let's say 2 if statements. So we can use multiple if conditions. So for example, if we want to create the multiplication or the square roots of the numbers which are even and for example they are multiplication of 10. Okay, let's say if we can find that. So we create another list. So list double condition equals to, for example, element, okay, for element in range, let's say 50, for example, I don't know, 50, if this element is even. Okay, so if element is even, if element, so element, sorry, if element is multiplication of 10. Okay, right. So we have 0, 10, 20, 30, 40. If we omit this one, okay, so we'll have all the square numbers. Okay, so we have from 0 to 48. Okay, sorry, I didn't write the square. Okay, the square, sorry. So for element, okay, so we have 0, 100, 400, 900. These are the square roots that are even. So if we sorry, the square numbers, not the squares. So if we add our condition, so we'll have 0, 100, 400, 900, and 1600. Okay, so here we use list double condition. We use two conditions. Here we use two for loops. Here we work with strings, and here we also write our expression, the for, the iterable, and our condition. Okay, with our condition. So this is for the list comprehension. For the dict comprehension is also the same thing. Let's say we create a dictionary, we call it dict1 equals to, for example, sorry, so 1, let's say 2, 3, for example, and 4. Okay, so this is our dictionary. We want to create also the square roots of the not the square roots, the square numbers of this number. So we have 1, 4, 9, 16. To do that, we can use the for using the update, or the method that we are using to add elements to our dictionary. So for element in dict1, for example, dot, let's say dot values. Okay, we replace dict1. Okay, for example, or let's say for key value. Okay, for key value in dict1 dot items. Okay, so we write dict1 str key is equals to the value, for example, square. Okay, run, and if we print dict1, we will get 1, 2, 3, and 4. So these are the square roots of the numbers. Okay, dict1 is replaced by this dictionary. Using the dict comprehension, we can write directly dict1, okay, squared equals to we create a dictionary. Okay, we said that we write the key value pair. Okay, for, let's say, key value in dict1 dot items. So here, for example, I have to change it. Okay, run that, because if we don't try that, it will create this dictionary. It will directly use this one. Okay, so here we write square root dot items, and it is a function. Run. So if you print dict1, this is dict1, and this is dict square, it will give us the first one. Okay, so here, for example, if we add the condition, it will be like the first one. We have 1 line of code, but in here we only use 1 line of code. Okay, so this is for the dictionaries comprehension. We use the key value pair, and we write our statement for an iterable in so we have here our iterable, and we add conditions if we want. Okay, we are going to talk about functions in Python. In Python, we have two types of functions. We have the built-in and the user-defined. Built-in functions are defined within Python, which means that they are ready to be used. For example, we have the print, the input, the absolute, etc. Python in total has 69 built-in functions. For the user-defined, we have two types. The function can be anonymous, which means that it doesn't have name, and we create that using the lambda keyword. Or it can have a name, and it is defined as the following. So it is a block of code that runs when it is called. It can be called anywhere after the function has been declared. It avoids repetition and makes the code reusable, which means that we define function once and we call it as much as we need it to avoid repetition, as we have said, and it makes programs more organized and manageable. Functions also can be nested, and we can use the global keyword inside the function to define a variable as global. So we start by the built-in functions. Okay, so we write print, for example, hello. This is a built-in function. We can also define our anonymous function, which is defined as the following. We write, for example, f equals to lambda. It takes x and it returns for us, for example, x to the power of 2. Okay, right. For example, if we put f of 5, it will give us 25, which means that it will take 5 here and it will return for us 5 to the power of 2, which means that 5 times 5 is equals to 25. Okay, so this is about lambda function. And now we define the type of function that is the most used. So to define that, we use the def keyword. We give it a name, for example, function1. We open the parentheses, and for example, we write our arguments. So we have, for example, 1 argument or 2 arguments, and we can write as many arguments as we want. We add a column, we press enter, and we define our documentation string. Okay, our doc string. This string, it is a comment that where you can specify what you want to do in this function, or what does this function do. For example, we can write this function calculates the, for example, the sum of two numbers. Okay, we come back to the line and we add return num1 plus num2. Okay, we run that. So here we have defined our function. So define our function. Now we want to call the function. To call that, we can print function 1. Okay, if you do this without arguments, so run function 1 missing two required positional arguments, num1 and num2. Okay, if we add only one element, so we write 2, run. So missing one required positional argument. So if we write your arguments as the following, these are required positional arguments, which means that when you call your function, you have to put the number of arguments which is equal to the number of arguments that you use to declare your function. So here we have to, for example, we calculate the sum of these two numbers. So we have 2 plus 3, it is 5. Okay, so these are called the parameters, and you have to put the number of parameters when you call the function equal to the number of parameters that you use to declare your function. Okay, if you want to define your function like the following, define function 2. So we write num1, for example, equals to, or we call it number 3 equals to, for example, 3, and you add here num4. Okay, you do the same thing, return num3 plus num4. Okay, so you are going to see the number of errors that we get here, or the type of errors that we get here. So we have non-default argument follows default argument. So this one is defined as default argument. Okay, what does default argument means? It means that when you call your function, you can either call it or give it another value, or by default it will calculate using the defined one. So here we have defined it by 3. If we call the function, it will use 3 directly. But when you define your default arguments, they have to be after the required arguments. Okay, so num3, which is equals to 3, has to be after your argument. Okay, or the non-default argument. So we run that and call function 2. We put only 4. Okay, function 2. So we have 4 plus 3, it gives us 7. Okay, so because we have defined this argument as default argument, so it is optional. You can add it or no. If we add that, we will change the number. Okay, so we'll have 4 plus 7, which is 11. Okay, but if we don't add it, we will not have an error, since it is a default argument or default parameter. Okay, so we have said that when you have the number of arguments, the non-default arguments here, it must equal to the number of arguments in here, which means that when you call your function, but when you have a default argument, you have the option whether you call it or not. So it's up to you. Now, if you want to define another function, define function 3, for example, okay, we don't put any arguments, okay, and give it a value here, for example, x equals to 10, okay, and we write print x, okay. If we call the function 3, it will give us 10, okay. But if we call print x, it will say that name x is not defined, because the variables that you define inside the function are local to this function, okay. You cannot use them outside of your function. If you want to do so, you have to declare your variable inside the function as global using the global keyword. So write global x, we run that, we call our function, give us 10, but now if we print x, it will give us 10, because x is not declared or is not defined anymore as a local variable to this function, because you have used the global keyword, okay. We can also define another function, for example, that has an input as for example, let's say a list. So create list 1 equals to 1, for example, 2 and 3, for example, okay. Run that, define a function, we call it, for example, list iter, okay, and we will have a list, for example, 1, and we will iterate over the sequence or over the list. So for element in list 1, print element, okay. Alright, so if we call this function, we say list iter list 1, so it will give us directly the elements of our list. We are going to talk about strings in Python. A string is simply a sequence of characters. To define that, we use the quotes. We can use single quotes. For example, we say hello world, right? Or we can use double quotes. So text 2 equals to double quotes, this is a string, okay. But we cannot use at the beginning single quote and at the end double quote. For example, if we write text 3 equals to single quote text, right, and here we change it to the single quote, it will say that there is an error about our string. The same thing if we let the double at the end and the single at the beginning, okay, so we'll have an error. If you want to define a string, you can use single quotes, double quotes, and we can also define multi-line string. Multi-line, for example, string, right, equals to, we write triple quotes, right. We define, for example, this is multi-line string, right. So we run that. If we directly call it by name, So we'll have the /n, which means that it did not understand exactly what this means. But if we write print multi-line string, it will give you a multi-line string, right? And it is the same thing if we want to use the single quotes, right? So we write here 2 equals 2. We have the same thing. This is using, for example, single quotes, for example, okay? And if we print that, print multi-line string 2, and we will have the same thing, right? So this is a multi-line string. And the same thing we cannot use at the beginning double quotes and at the end the single quotes. We'll get an error as in here, okay? So to find the length of the string, we use the length function. So we have 33 characters. We can also use the type, okay? It is str, which means that it is a string, okay? So if we come back to our character, for example, text2, right? Copy that fast, okay? So here, for example, we can use indexing. Since it is a sequence, we can access any element that we want in our string, right? So we have the length, it is 16. For example, if we want to print the character number, for example, let's say 4, we'll have O, okay? Sorry, this is text2. So we have space 0, 1, 2, 3, and the 4 is space, right? For example, if we want to print the first element, so we use, it starts from 0, okay? So this is first element, and the last element, text2, we write -1. Here we get the last element, okay, which is J, it is G, and the first is T. So this is about indexing. We can also access a part of the string, okay, so using slicing. For example, if we want to print text2 from 4 until the end, okay, so we use the colon and it will print us the space is a string, right? For example, if we just want to print the first word here, we use from the beginning until the fourth. We have this, okay? So this is about indexing and about slicing. For example, if we want to change a character, let's say for example the last character, so we said that last character is G, so we write text2 dot replace, for example, where we have G, we replace it by, for example, let's say S, okay? So this is, it doesn't have meaning, but I mean you get the idea. So if we write, for example, text2 replace, okay, and we replace, for example, S by, for example, let's say W, we will have all the letters S will be changed by W. So we use replace to change a character in a string, okay? We can also, for example, print, okay, let's say print this is a sentence, right? And here we have, for example, word equals to, we use the escape character n, which means new line, and we write new line. Okay, and for example, if we print word, right, we will have this is sentence, and we have a new line. Okay, so for example, if we want to use /n, it means that escape character plus the n means a new line. Okay, so if you want to print a new line, you use /n. Also, if for example, if we want to, if we want to write print, okay, for example, svm is and we write, for example, double quotes, very, okay, important, for example, algorithm in machine learning, right? For example, we want to highlight this word, right? We want to say that it is very important, for example, algorithm, right? And if we run that, we will have an error because we cannot use word inside quotes inside a string. Okay, to do that, we have to use a character which is called escape character. Okay, so we write escape character, right, and we add it in here. Okay, so once we run that, we have svm is a very important algorithm in machine learning. So the escape character allows to use the double quotes when we are normally not allowed to. Okay, so it is very important to note that if you want, for example, to highlight a word inside your string, right? We can also concatenate two words. Okay, let's say, for example, word 1 is hello, okay, and word 2 is, for example, world 1. So if we print word 1 plus word 2, we will get concatenation. Okay, but here we have the two words are stacked. Okay, we can add a space, so we write, for example, word 1 plus space, okay, plus word 2. Fine. And here we have hello word. The two words are concatenated, and also we have added space between them. Okay, so this is about concatenation in strings. There is also the format character or the format function that we use in our strings. Okay, for example, you write, for example, weather. Okay, we call it, for example, good weather, or it is only, say, for example, good, and what we can add, for example, we say weather is good, and the season, for example, we say season is summer. Okay, we're on that. So we have defined two strings. If we want to print that, okay, so we say print. Okay, we can use the double quotes, right, and we use the curly brackets. So we say here, for example, the weather is good since we are in summer. Okay, so here what you can add is you can add the function dot format, right, and you can add your strings in here. So we have for weather, and we have the season. Okay, if we run that, we will get the weather is good since we are in summer. Okay, so the format function allows us to, for example, we can change the strings anytime that we want without changing all the function or all the string. Okay, for example, we say here the weather is bad since we are in, for example, winter, right? Run. So the weather is bad since we are in winter. Okay, so this is called the format function. We can also use it as the following. So write print, this is the second method. You write f, double quotes, and you write here the weather is curly brackets. Now we'll enter the name inside the curly brackets, right? So the weather is good since we are in. You do the same thing. You open the curly brackets and you add your string in here or your name in here. Okay, so it is the same thing. You can either use this method or this one. Okay, me personally, I use this one since it is much simpler and it is faster. Okay, so it is up to you to choose what function you want to use for the formatting function. Okay, we have also some other methods. For example, if we write, we have here the weather is a string, right? And here we will have all the functions that we can, or the methods that we can apply to our string. For example, if we write upper, okay, it will give us the noun with the letters capitalized. Okay, so for example, if we define another word here, we say word is, for example, hello, run that, and we want to transform it or to have the lower cases. Okay, so we write word, press tab, and we search here for lower. Okay, word lower, it will give us the lower letters of the word. Okay, so we have upper to capitalize your word, and the lower to make it to have lower cases. Okay, for example, if we define another let's say text equal, this is a new Python tutorial, right? We run that. For example, we want to count the number of t's in our text. So we write text dot count t. So or you can just directly write t. Okay, as you can see here, name t is not defined. Okay, so since we are working with strings, we have to add the single or the double quotes. Okay, so the count function will count the number of times the string that you will put in here is present in the sentence. So the t is 1, 2, 3, and normally it is 4. But since we have the difference between the capital letter and the lower cases, so we have 1 t with capital letter and the remaining with the lower cases. Okay, so this is to find or to count the number of strings. We can also use a word, for example, tutorial. Since tutorial is present one time, it will say that it is present one time. Okay, and for example, if we want to find text dot find, okay, to find the index of for example the string that we put here. So we have Python, it will say that it is in position 15. Okay, so we have 0 1 2 3 4 5 6 7 8 9 10 11 12 13 14. So it starts from 15. Okay, it will indicate the first string where it started. Okay, so this is find to find where the string is located. For example, if we say p run, it is the same thing. Okay, since Python starts with p. For example, if we write I run, it will give us the first one. Okay, so 0, so 0 1 2 3. Since we have space in here, so we have the first position. It will not say to us the second one or the third one. Okay, it will always give us the first one in the string. Okay, so the smallest index. Okay, so this is about the find function. We can also use title, for example. Okay, let's say text dot title. It will give us a string that all the words will start with capital letter. Okay, so we have capital letter, capital letter, capital letter, and capital letter. Okay, so the title will give us all the words in the string, and it will modify it in a way that they will all start with a capital letter. So here we have the lowercase, here we have the uppercase, P, P, T, and T. Okay, so this is about the title. For example, if we add spaces in here, okay, at the beginning and at the end, we can use a function which is called strip. Okay, that will remove the spaces from the beginning and from the end of our string. So here we run that, we count 1 title. Okay, so text.title strip. So as we have said, it will remove the spaces at the beginning and at the end of our string. Okay, we have also another function that is very used, which is split. For example, we write text dot split. It will return for us a list that contains all the words that are separated by a space. Okay, so here we have removed the spaces at the beginning and at the end, and it will separate the string depending on the spaces. Okay, we have space, 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 and space. For example, if we define another word, so we have text 3, for example, equals 2, and we define that by this string. Okay, we put this string in here, and and we add commas. Okay, to remove the spaces, we add commas, right? If we run that, so if we do text dot split, it will do it on the space as we have said in here. But if we change it to 3, it will give us this string. Okay, since we don't have spaces. But if we choose the separator as a comma, it will give the same thing. Okay, so the split splits the string depending on the separator that you will define in here. Generally it is the space or the comma. Okay, we are going to talk about namespaces and scopes in Python. These are very important because they will give us a good understanding of how really functions and variables are worked or are mapped in Python. And of course, this also will help us later on to understand the concepts of the object-oriented programming in Python. So, a namespace is a mapping from names to objects implemented as dictionaries in Python, which means that unique name for each and every object. As you know, Python dictionaries have key value pairs. The keys are unique, so we cannot find two keys that have the same name in Python. Thus, namespaces in Python are used to map each word to the object or to the corresponding value. For example, for integer, if you give it x equals to 3, so we have the name x and we get the object from the memory location. Okay? Namespaces are created at different moments and have different lifetimes. As we will see later on, we have different types of namespaces. For example, when you define a function, you create a new namespace. When you open a new program, you have your new space. When you close your program, you close your namespace. When you execute a function, so you close your namespace, etc. A scope is the textual region of Python program where namespace is directly accessible. For example, if we define a function, we give it a name and we give it variables, we will have local variables. And this scope is where the namespace is directly accessible. So for example, inside the function, if you define your variable, you call the variable inside the function, you will get the result. But if we call it outside the function, it will say that it is not defined. Okay? A lifetime of a namespace depends upon the scope of objects. If the scope of an object ends, the lifetime of namespace also ends. As we have said, if you declare your function, you define your variables, then you execute the function, which means that you have ended your execution, the namespace will end because the scope has been executed or the code has been executed. We have four types of scopes and namespaces. We have the local, as we have said, inside the function we have the local variables. We have the enclosed, which means that it is defined inside the nested functions. It is not global and it is not local. It is between them. And we use the non-local keyword to define these words if we want to use them in our functions or in our programs. We have the global, which means that what we define in the main program, okay? Or we can use the global keyword to define the global scope. And we have the built-in, which means that what we have inside the modules. For example, if you want to import a number such as pi, which is built in using the math module. To understand more about that, we will start by examples. So here we start from, for example, the built-in scope. Okay, so we have print, for example, hello world. Okay, since we have a built-in function, so this is a built-in scope, right? That we have said earlier, for example, from math import pi, okay, and write pi. So here we are also in the built-in scope, right? Because we use the built-in functions and the built-in variables, right? Now, if we want to define a global keyword, for example, x equals to, let's say, global variable, right? So if you print x global variable, okay, so here we are in global scope since we are in the main program, okay, so this is a global scope. For example, if we want to define a local and the enclosed scope, we use a nested function. We start from def outer, right? So here we define another function, def inner, right? And inside the second function, we define x equals to, for example, local, okay? Print x. And between the functions, so here we are in the main program, right? Main program. Here we are in the local because we are inside the function, and between the local and the global we have our enclosed. So here x is enclosed, right? And we run our function in here, run. So here we have our inner or our local keyword, our local scope since we are inside the function, okay? And between the functions we have the enclosed keyword, right? It will print local. We are going to talk about very used module in Python, which is a random module. Random module is a Python built-in module which is used to generate random numbers. For example, to start, we import the random module, right? If we want to generate a random number, for example, a float, which is between 0 and 1, we use the random function or the random method, right? So this to generate number which is between 0 and 1, and it is a float, okay? For example, if we do that again, run, we will get another number. If we do that again, we will get another number and another number which is different. So if you want to get, for example, the same number, we use a method called seed. Okay, so for example, you import random.seed and you put here, for example, 0, okay, run. So at each time we'll get the same number, okay? If we remove that, we'll get another number, okay? So the seed method will keep for us the same number, okay? So it will always generate the same number. Now if we want to generate a float between two numbers, for example, let's say 1 and 10, okay, so here it is between 0 and 1, and now we want to generate a float between 1 and 10. We use the method called uniform. We give it the beginning and the end, okay? So we run that, we will get 7.82, for example. We run that again, we'll get another value. Run that again, we get another value. And the same thing, if we want to get only the same value, we use the seed function or the seed method. So as you can see here, we get always the same value, okay? Now if we want to generate an integer between two values, we use random.rand int, okay? And we give it, for example, between 2 and 12. It will generate for us a number, okay? run, run. Okay. Now let's say, for example, we create a list. So we call it list1 equals to, for example, list range 11, right? So if we get list1, we'll have this list. If we want to shuffle our list, we use the shuffle method. For example, we write random dot shuffle and we put list 1. Okay. Now if we print list 1, it will give us the list shuffled. Okay. If we want to get a random number from the list, we use the choice method. So we write random dot choice and we write list 1. So it gives us 9, 5, 0, etc. We can also use the seed method if we want to get only the same number. Okay. We have also choices. So we write random dot choices and we write list 1. We also since we want to get more than one choice, okay, so as you can see here we have the s, we can write the number of k's that we want. So for example, let's say k equals to 5. So as you can see here we have a repetition, so we have 8 and 8. If we want to get a sample or an example without repetition, we use the sample method. For example, random dot sample, write list 1, k equals to 5. So as you can see here, we don't have repetition. So choices and sample do exactly the same thing, which is picking up random variables depending on k that you have put in here. And for sample, we don't have repetition of the values, whereas for choices, we have repetition. So it allows repetition. Okay. And also for choices, we can get a number, for example, which is greater than the length of the list. For example, if you write length list 1, so here we have 11. Since choices allows for us to get repetition, for example, we can put k is greater than 11. For example, we put 15. So we get here another sample, which has 15 values and has repetitions. But for sample, if we put 15, we'll get an error, because for sample, since it does not allow repetitions, we cannot put the value of k greater than the length of the list. Okay, so the maximum value, for example, here is 11. All right. Now let's say, for example, we want to create a list that contains 15 elements, and these elements are integers between 1 and 6. Okay, so we create our list, so we call it my list 2, and we use a for loop. So for element in, we said 15 elements, and we have values which are random and derived integers between 1 and 6. So we append that to our list value, right? And we print our list. Okay, so here we have 15 elements. which are between 1 and 6. Okay, and it is the same thing if you want to create a list that contains random values which are floats. Okay, so for example, we have my list 3. We do the same thing for I in range, for example, 10. Okay, we create our number, which is a float random dot uniform. Okay, which is between, for example, 1 and 5. Okay, and we append that to our list. So my list 3 dot and our number, right? We print that my list 3. Okay, so here we have 10 elements. Length of my list 3 is 10. Okay, and all the values are between 1 and 5, and also they are floats. Okay, we are going to talk about the object-oriented programming in Python. As you know, everything in Python is an object. So understanding the concept of the object-oriented programming is very important to be good in programming in Python. To start, we have a definition of the object-oriented programming, which is a programming paradigm that uses objects and classes in programming. We have a class versus object. A class is a design or a template for objects which defines the attributes and the methods, whereas the object is an instance of a class that is defined using these attributes and has the access to use these methods. As you can see here from this picture, we have a design of a car, which is the blueprint, and once this design is validated from, for example, the managers or the designers of the company, and it is allowed to be commercialized, then the company will produce the cars which are considered as objects from this class. So here our object is Audi, Nissan, Volvo, for example. These are famous brands of cars all over the world, and they are instances of the class which is a car. And then of course each object will have its characteristics and the things that distinguish between this category and the other one. Attributes and methods. An attribute is a variable stored in an instance or class, whereas a method is a function stored in an instance or a class. We have three types of methods. We have static method, class method, and instance method. As you can see here, for the static and the class, they depend on the class by itself, whereas the instance method depends on the objects. Instance method has self as the first argument. Class method has CLS as its first argument. Static method has no arguments that have to be as input, so it is optional. We have two types of variables. We have class variables and instance variables. Class variable is defined inside the class and outside the instance method. Instance variable is defined inside the instance method. The constructor. A constructor is used when the class object is created to initialize the members of the class. In Python, the init method is called a constructor and is always called when an object is created. Types of constructors. There exist two types of constructors in Python: default and parameterized. Default is defined with no parameters. We only put the self as the only argument. For example, we define init, the self, and we set our value to 10. Parameterized is with self as the first argument plus other arguments. For example, we define our init function or constructor with the self, arg1 and arg2, and we use the self.arg1 to set the value of arg1 and self or argument 2 equals to the argument number 2. Self is used to represent the instance of the class. By using the self keyword, we can access the attributes and methods of the class in Python. Inheritance. Inheritance is the capability of one class to derive or inherit the properties from another class. Parent class or base class is the class being inherited from. Child class or derived class is the class that inherits from another class. So, to understand more classes and the object-oriented programming in Python, we are going to define some classes and objects so that you will understand more classes. So to define a class, we write the class keyword and we define, for example, a car class. Okay, so write class car, press enter. We define our constructor. So we define our constructor init and we write the self. Okay, for example, we want to define our car by the model and the year. Okay, so we write self dot year equals to year and self dot model equals to model. So here we have defined our car class, which is defined by two parameters, the model and the year. To create an object, write, for example, my car equals to car. If we just write car without arguments, we have an error. In it, missing two required positional arguments, the model and the year. So we have to enter exactly as the same order. So we write, for example, OD and, for example, 2020. Okay. So here we have defined our class, which is called car, and our object, which is called my car. Okay. To access, for example, the elements of our car, we write my car dot, for example, model. We have OD. My car dot year. We have 2020. Okay. So we call this the constructor. Okay. Now, if you want to define an instance method, we copy that. Okay. For example, we define a function. We call it def get model, and as we have said, for the instance method, self has to be this first argument. Okay. So we write def get model self return self dot model. Okay, or we can add another one, for example, def get year and we write self return and we write here return self dot we said the year. Okay, so this is called instance method, and this also is called instance method, right? Since it has self as its first argument, so it will have the access to the properties of the class and the object by itself. Okay, so for example, we define the same car here, my car. Okay, so if we write my car dot get model, we'll have the model. If we write my car dot get year, we'll have the year. Okay, so the instance method have the access to the properties of our object. Okay, whereas the static and the class methods that we are going to define, they do not have the access to the object properties. They only deal with the class by itself. Okay, for example, to define static method, so we copy that. Sorry. So we copy that. All right, and to define a static method, as we have said, it can contain arguments, optional arguments, or we can define it without any parameters. For example, we start by static method, right? Static method, right? So we write def, for example, information, so we can write information. We print. This is, for example, a class to define car. Okay. If we run that, we define our object. Okay. And if we write my car dot information, we'll have this is a class to define a car. So this is a static method. It does not require any argument, like for example the self argument. Okay. We can also define another static method with our optional parameter. Okay. So we write add static method. We define, for example, we want to know if our car is a sport car or not a sport car. So we write is, for example, sport car. Okay, and we are going to define parameter, for example, as max speed. So if max speed is greater, for example, than 240, return true. Okay, else return false. Okay, for example, so we have defined our car and we write my car, for example, dot is sport car, and we write, for example, 100. So it is false. But for example, if we write my car dot is sport car and we get, for example, 300, so we'll have true. Okay, so this is a static method that contains one argument. Here it is not optional. Okay, so if we write this, for example, my car, okay, without arguments, it will say to you that is sport car missing one required positional argument. Okay, so if we define it here by an argument, you have to call it with an argument. If we define it here without any arguments, so it will directly give you the output without any required arguments. Okay, so now if we want to define the third type from the methods, which is the class method. Okay, so for example, we define our class and we want to know if our brand is from the best German brands. Okay, and we have said that always the CLS, which is class, is the first parameter. So to do so, we are going to define a class variable. Okay, that we are going to call it, so we call it top, for example, 5 German brands, for example, car brands. Okay, and we are going to define a list. For example, we are going to write Volkswagen, for example. Okay, we are going to write Mercedes-Benz, for example, Mercedes-Benz. We are going to write, for example, Audi, right? BMW, and for example Porsche, right? So here we call this class variable, okay, and we want to know if our model is from the top 5 German car brands. So to do so, we add here another parameter which is model, okay. So we say if our model in, so we are going to access our class variable using the CLS dot, so we're going to copy that, so it is a list. So if model is in our list, so we print the model, for example, is in top 5 German brands, okay, for example. Else we print or we return false, or we print directly, okay, it is not. Else we print the model is not in, for example, top 5 German brands, okay, for example. Okay, so for that define our car, right? So here right here, okay. And for example, if you want to write for example my car dot, so we have here best German brands, and we write for example here Dodge, right? Dodge. So we have the model is not in top 5 German brands. Whereas if we write my car, for example BMW, so we have the model is in top 5 German brands. So here the class method has CLS as its first argument, and it only deals with the class, so it does not have the access to the properties of the objects, okay, which is going to be useful if you want to deal with the class methods, okay. So we have three types of methods. We have the instance, we have the static, and we have the class method, okay. We are going to talk about inheritance in Python. Inheritance allows us to define a class which has the capability to inherit all the methods and properties from another class. The class that is being inherited from is called the base or parent class. The new class is called derived or child class. To understand that, we can start from an example. First, we can define a class which is called employee. We can add a docstring that says this is a class to define an employee in a company, for example, and we define our constructor. To write def init, we have self, and we add a list of skills, so we call that skills list. We set self dot, so skills list equals to skills list, and for example we define a method that says if, for example, this employee is a data scientist or not a data scientist. To do that, for example, we can write if is data scientist, or let's say analyst, write the self, and we define our data analyst skills. So we have data analyst skills. For example, we can write, we have R, for example, we have SAS, we have, for example, Python, for example, statistics, statistics. Okay, we can add, for example, calculus. We can add linear algebra. For example, we can add so SQL or no SQL. We can add, for example, data cleaning. So data cleaning, for example, data visualization. Okay, so for example, we define our data analyst skills and we add another list. For example, we call it comparison. Okay, so for skill in self dot skills list. So if the skill is in our data analyst skills, so we append that to the comparison list. So we write comparison dot append skill. Okay, else we pass. Okay, now for example, we can say that this employee is data analyst if it has at least 4 skills from our list. For example, we can write if length of comparison list is greater than 3, so we return true, else we return false. Okay, so run that. So we define, for example, my list 1. So let's say, for example, we have R, SQL, and Python, for example. Okay, so we run that and we call our class. So we define E1 as employee, so we have to put our argument in here. So write my list 1. Okay, and we want to know if this employee is data analyst. So is data analyst. Okay, run that. So we have here, okay, I have list return false, right? So it says that it is not data analyst because we only have 3 skills. Okay, for example, if we define my list 2, for example, we write this, and for example we can add here calculus. Okay, so we run that and we define our employee as 2. Okay, so is E2 data analyst, for example. So we have true. Okay, Now we have defined a class of employee, and we have defined a method that says if this employee is data analyst or not. Now we want to create another class that we'll call class senior employee. Class senior employee. Okay. And we will inherit the employee class. So we will have all this in our new class. Okay. So we call employee between the parentheses, and we have to add another parameter, 1 or 2 or 3 parameters. So to do that, we need our constructor. So we write def init. So we call self. We have skills list, and for example, we can add experience. Okay. Now there is a method that is called super, which is used to get all the methods and the properties from the employee class. Okay, so we write super dot init, and we have skills list. Okay, now we have also to define our new variable, which is experience. So we have another parameter. Okay, now like this we have inherited all the methods and the properties from the employee class. So we want to know if, for example, this employee is a senior data analyst. To do so, we can define another method, call it is senior data analyst. Okay, so we call our self, and we say that if self dot is data analyst, so we call our method, which is data analyst, and we will compare the experience. So if self dot experience, for example, is greater or equal to 5 years, then we print yes, this employee is data analyst, a senior data analyst, for example. So this employee is a senior data analyst. Okay, else print, for example, no, this employee is junior data analyst, for example. Okay, no, this employee is a junior data analyst. Okay, so else, so if it is not data analyst, we directly print this employee is not data analyst. Okay, print, so this employee is not data analyst. Okay, so if we run that, now we can use the lists that we have defined in here. For example, we define our employee, so E3 equals to senior employee. Okay, and we write here, for example, our first list, my list 1, and we write here 6. Okay, so if we want to know if this employee is senior data analyst, so is senior data analyst, so it says that this employee is not a data analyst. Okay, because we have compared this comparison list with our skills list. Okay, and it is equals to 3. Okay, so it has directly used this method even though we didn't define it in here. So as we have said, super is used to inherit all the methods and the properties from the parent class. Okay, now if we define another employee, for example e4 equals to, for example we call that senior employee. Okay, and we call the list number 2. We add here, for example 4, and we run that. So if we want to know if this is a senior data analyst, we can just say that. So since we have 4 years, it says that no, this employee is a junior data analyst. Since we have 4 years of experience, so self.experience is not greater or equals to 5, and we have the number of, or the length of the comparison is equals to 4. So it is a data analyst, but it is not a senior data analyst. Now if we define another employee, call it E5, and we put here, for example 7. Okay, and we want to know if this employee is a senior data analyst. So write E5 is senior data analyst. Yes, this employee is a senior data analyst because my list 2 contains 4 skills that are included in our skills list, and we do have years of experience that are greater or equals to 5 since we have 7. So it says that yes, this employee is a senior data analyst. So the idea here is that we defined a child class that has inherited all the properties from employee class, which is in our example, the method for example is data analyst. So we don't need to write that again in our class in order to use it. We can only use inheritance and using the super function to inherit all the methods and the properties from our parent class. A file is a collection of data or information that stays in the computer storage devices and has a name. We can find the files in 2 types. They can be in text format to store characters and strings, or in binary files which used to store images, audio, and videos. In Python, we have to follow these 3 main steps. First, we create the file, or we open it if it exists. Then we perform the following operations. We can read, we can write, or we can append data to our file. And finally, we have to close the file in order to proceed with the following instructions. Now we are going to talk about the file opening modes in Python. The main function that is used to open the files is the open function. We have here the syntax, which says that open, you open your parentheses, you write your file name, then you precise the opening mode. We have 4 main opening modes in Python. We have R, which is used to read the file, and it is the default mode. It returns an error if the file does not exist. A is used to append data to an existing file, and it creates the file if it does not exist. W used to write data to an existing file, and it creates the file if it does not exist. But if the file already exists, then it will be overridden, which means that we have a difference between append and write. In append, we can only end data without overwriting the existing data. Whereas in the write mode, if the file already exists, what we are going to write will override the existing lines in our file. And finally, X is used to create the specified file, and it returns an error if the file already exists. We can also specify the file type, T for text mode, and it is the default mode, and B for binary mode. For example, we can assign our file by writing my file equals to, we write the open function, we write the file name, which is data file name.txt, and we open it in the read mode and in text mode, which means that the file type is text. We can also use the blind sign for updating files. For example, if we want to read and write data into the text file, we can write r+. And for example, in this case, the data in the file will not be overwritten. To delete a file in Python, we can use the operating system module, OS module, and it is written by the following. We import OS, we write os.remove, and you specify the file name. Now, for example, if we want to open a file, we can write file equals to, write the open function, we open our parentheses, and I have a file which is called file.txt, and we are going to open that in the read mode. Okay, now if we want to print the content of our file, we write print file, and we use the read function. Okay, so here we have the definition of a computer file. After each operation, you have to close your file, so you write file dot close. So here to close the file. Okay, now if you want to open that again, we write, for example, the same, file equals to open file txt in the read mode, and let's say, for example, we want to print the 10 first characters of the file. So we write print file dot read, and we write 10. So it will print for us the 10 first characters of our file. Okay, and also we have to close that. Now there's other thing that we can do. For example, we can read our file line by line. So we call that again file open file.txt, right? And we write file dot read line. Okay, and we print that. So it will give us the first line. Okay, so if I want to do that again, it will give me the second line, and if I do that again, it will give me the third line. Okay, so we have to close that. So as we have said, the write mode, it will write directly into a file, and it will overwrite the file if it exists, or it will create the file if it does not exist. Okay, so file2 equals to open my file2.txt, and we do that in the write mode. Okay, so we have our file, and we can write whatever we want. So for example, we write file2, we use the write function, and we write this is, for example, the second file. Okay, and we close that, file2 dot close. Okay, now if we want to read our file, so we call that, for example, file2 equals to open, so we call the name my file2.txt, and we use that in the read mode, and we write print file2 dot the read function. Okay, so we have this is second file. Now we have to close that, file2 dot close. Okay, if you want to append data to this file, so we have said that it will not overwrite the previous data, it will directly add the data. So if we open the file again in the append mode, okay, so we write file2 dot write. This is the second line. This is the second line. Okay. So now, if we want to open our file again, so file2 equals to open my file2 dot txt in the read mode, and I print file2 dot read. Okay, so I have the two lines stacked. Okay, now what we can do is that we have to add something that specifies the new line symbol. Okay, to do that we have to add the \n. Okay, so for example, if we close that, so we write file2, so I close this one, file.close. Okay, now if I'm going to add this \n to the append, so file2.append, and I will call the \n. Okay, so file2.close and open that. You see, so the \n specifies that the new line will be in another line. Okay, it will not be stacked anymore. Okay, so be careful if you want to add new lines, and the new lines or the new data or the new characters, you don't want them to be stacked. You have to add the \n to specify a new line. Okay, so this is used to specify a new line in Python. Okay, now if I close that and I want to overwrite all this, so I have to open the file2 in the write mode and write something new. Okay, for example, if I want to do that, so I open this file again in the write mode. Okay, and I want to add something, for example, file2 dot the write function, and we write data is overwritten. Okay, now I have file2 dot close. If I call that again, all this data will be overwritten and I will have only the new line. Okay, so data is overwritten. Okay, we can also use another function or another method if we want to print a file or want to read a file, as we have here. So we have the file.textr, which is the following. So we write with open file.txt, and we write that in the read mode, for example, as file. Okay, so we write, for example, print file.read. Okay, that's just an example. Or you can assign, for example, file.read. So you have your data, you assign your lines or your file to data, and then you perform some instructions that you want. For example, write there instructions. Okay, depending on your task. So this is a method that is very used when working with files.
So we have arrived at the end of this tutorial. Thanks for watching and see you in the next tutorial.